Well, hello everyone, welcome back to Dprieto TV. I hope you like travel tidbits, but finally since January, we are back with Prietology Season 5. Wow, this is the fifth time, this is the fifth season we're doing. This season, like I said, all the way back in January, it's been a while. We're talking about astronomy this time, some great stuff. We're going interstellar, we're talking about the planets, stars, moons, galaxies, even black holes we'll even be able to get into. So yeah, like I said, I hope you enjoy travel tidbits, and remember that this is the last season of Prietology that I will make on this channel. It's expected to last the end of the year, considering how many episodes I'm doing. So yeah, enjoy this last season, the grand finale season. We've talked about chemistry, physics, biology, geology, and now we're doing probably my favorite out of all of them, astronomy. So yeah. Let's go over the key terms. We got some announcements at the end. So yeah, this is episode 1 of 8, just to show you how long this is already. So yeah, let's go over the key terms. I've kind of changed things up a bit. So yeah, let's go. Alright, so as we head into the final season of Prietology, we go over our first episode, the basics of astronomy. So yeah, we have, I'm counting really quick, 7 key terms to start us off. Essentially how we're going to work. We're going to start with the solar system, and we're dividing that up into 3 episodes. This one, we're talking about the inner solar system. So we have Mercury, Venus, Earth, meteorite, the Moon, Mars, and the asteroid belt. Just to start off the solar system. So yeah, let's get started with our first term. Alright, let's start off season 5 of Prietology, term number 1. So yeah, we're talking about good old Mercury, the closest planet to the sun. As we know, our famous solar system, all our planets that surround it, is the closest to the sun, but surprisingly it is not the hottest planet in the solar system. Another cool fun thing about it is that it's named after the Greek Roman god. They share the same gods, the messenger of the gods, Mercury, or Hermes. That's the Greek name of it. Supposedly, or not supposedly, it is very, very hot during the day. Just saying that it's not the hottest planet in the solar system doesn't mean it's burning. High of 806 Fahrenheit is probably the highest ever temperature, so you can imagine a daily temperature. So absolutely scorching during the day and freezing cold at night because it does not have an atmosphere, almost no atmosphere whatsoever. So temperature changes are massive. So burning hot temperatures of 700 degrees during the day, and at night you can get down to minus 200 degrees Fahrenheit at night, because essentially just bare naked in the vacuum of space. So big temperature shifts in this planet. So one thing that it used to be very while ago, it used to be very hot and molten, being so close to the sun, and now after many years, like thousands of years, the core has cooled down significantly to what it was thousands or possibly millions of years ago, and since that, cold things shrink, so that means the entire planet technically is shrinking with it, causing wrinkles along the surface. So there's a lot of like jagged parts along the surface of Mercury. If you go there, which I don't think you can, because you'll die if you step on there. But yeah, the surface is shrinking. The entire planet is essentially shrinking, so kind of like crumpling itself up, kind of like squeezing itself into itself. So yeah, some fun fact about Mercury. We're continuing fun facts in the season. Some fun facts about Mercury, or a fun fact about Mercury, is that there is ice on its caves in Mercury. Considering that, like I said, anything that essentially is facing the sun gets super hot, but considering the caves, they reach no light, they are not facing the sun, essentially they're facing the vacuum of space every single day, freezing cold, probably the coldest parts on the planet itself. So yeah, pretty cool. Alright, second term, we are going to the second closest planet in the solar system. We're going out of it. Venus, the second closest planet to the sun, named after the Greek Roman goddess Aphrodite / Venus of love and beauty. It does not live up to its name, surprisingly. It is not loving, it is not beautiful, it is a deadly place. You will never be able to step foot in that. The second you do, you're gone. The hottest planet in the solar system, beating Mercury by over 100 degrees Fahrenheit due to its greenhouse effect. The greenhouse effect is essentially, well, you know greenhouses, that's where you store plants. Like, here's a picture of a greenhouse, that's where you store plants in, so they can get more direct sunlight, more energy from the sun. So how the greenhouse effect works on Venus is that the most of the atmosphere is made out of carbon dioxide, and the other one is sulfuric gas and sulfuric acid, which we'll talk about in a bit. So most of the atmosphere being carbon dioxide, is all the heat that reaches it, considering it's pretty close to the sun, it hits it and it's trapped there. That's why they use greenhouses to cover plants so all the energy of the sun can be there. The carbon dioxide atmosphere traps all the heat inside so it can't escape almost, and all of it's just locked in and building and building and building and building. And yeah, that's what makes it the hottest. It has a deadly environment. Not just considering the heat, it is also deadly because it has a crushing pressure. All of that carbon dioxide itself is a very heavy gas. There's a lot of stuff in it. And considering that there's a ton of it, almost the entire atmosphere it is the same pressure as 1 kilometer going 1 kilometer under the ocean. Absolutely crushing you. It would crush you in an instant. Has toxic sulfuric acid rain once in a while. By once in a while meaning like almost all the time. It's raining sulfuric acid that'll melt your skin off easy. And yeah, sulfuric acid rain. The air is also super toxic. It's super heated, so it burn your lungs to death. So yeah, named after the goddess of love and beauty, but trust me, it is not loving and it is not beautiful. Fun fact, the highest point is the Gula Mons volcano. Yes, there are volcanoes on Venus, another thing that doesn't make it loving and beautiful. Are they active? I am not sure. I think some are, some aren't, so it kind of depends where you are. But yeah, the Gula Mons volcano, the highest point on Venus. Not saying that you'll ever be able to see it because rovers and stuff we send in, they last 8 minutes and then they're gone. So yeah, not the most pleasant environment to be in. Yeah, let's move on to our home. Alright, third closest planet to the sun, and our home in this ginormous galaxy we live in this infinite, possibly infinite universe that we live in. Good old Earth. Third planet from the sun, and like I said, our home in the solar system, the galaxy, the universe. The only planet in the entire solar system with surface water. Specifically, like you heard what I said, surface water. No other planet has surface water, but I'm not saying that no other planet has water. We'll get into that in a bit, and stay tuned to know other planets that have surface water, and other moons as well. It's in what scientists call the Goldilocks range. So Venus, as you know, boiling hot, you die in an instant. Mars, on the other hand, is freezing cold. We'll talk about that in a bit. So it's not too hot like Venus, it's not too cold like Mars or like other planets. It's in the perfect range, perfect temperatures, and that's why I'm able to film this video for you guys, why the camera hasn't melted, why there's electricity, while there's stuff, why I can go outside even though it's 115 degrees outside right now in Arizona, but still survive. The spinning outer core of the Earth, it has the spinning outer core, as you know, the layers of the Earth, it has the crust, the mantle, and the two cores, the outer and the inner core, is made of molten iron. So it's essentially liquid. It's like a Play-Doh consistency. It's super thick and obviously boiling hot. It rotates around it, and that creates the Earth's magnetic field / current. All the current of the magnetic Earth, all the fields that we have created, that is created by the spinning outer core. And those magnetic fields help block the Earth from radiation and all the deadly like radiation and UV rays that are bombarded by the sun. So yeah, good thing that we have a spinning outer core. Otherwise, we would die. All right. Fun fact: there is actually something called an astronomical unit. It's a measurement of unit, and that is the same distance as, it's actually defined as the distance between the sun and the Earth. That is one astronomical unit. One astronomical unit, the sun and the Earth distance. Yeah, that is used to measure galaxies and other solar system distances, star distances, a ton of other stuff. So yeah, it is pretty big considering it's millions of miles. So yeah, that just tells you how powerful the sun is. Being millions of miles away, we're still able to get its gravity and still able to receive its heat and energy. So yeah, let's move on to some other cool ones. Alright, we are on term number 4. We got 3 left to go. Meteorite. That's not a word you hear every once in a while. Essentially, in a simple layman's terms, it's a space rock. Literally. That's almost a way to define it. I actually saw that's essentially the definition. It's a space rock. It's a rock that comes from space, and it's usually the small rocks that make it all the way to the surface. Now, this is something I really want to talk about, the definition or the difference between meteorites, comets, and asteroids. You think, oh, they're just all the same thing. No, they're not. Like I just said, meteorites are space rocks that come all the way down to the surface and hit it. Small space rocks, not like the one from Armageddon, the size of San Francisco or something like that. Small space rocks that come and hit the surface, that make it all the way through the atmosphere. And those are the ones that are usually make craters on the Earth. Like there's a crater not too far from here in Arizona, I think. Comets are essentially snowballs. They're essentially just balls of ice and rock, primarily ice, that shoot along through, that pass by planets. Like, you wouldn't usually see a comet passing through here. Like Halley's Comet, that's a famous one passing by here. And I think in the next 40 years it'll come back. So yeah, essentially mostly snowball. They have the tails, the melting ice and the heat created by the sun is what makes the tail. And yeah, and asteroids are the ones that you see in movies that destroy the Earth, like Armageddon or Deep Impact or something like that. So, and the ones that are usually in the ones that usually burn up in the atmosphere, those are usually meteors, not meteorites. Meteorites are the ones that get all the way down to the surface. Meteors are the ones that get into the Earth, small space rocks, but burn up in the atmosphere because there's so much friction. Also known as shooting stars. That's what a lot of people like to call it. That's actually what I call it. Scientists also say that sometimes meteorite can be its own rock. Usually it's not something that can be found here, so essentially sometimes they classify meteorite as their own rock, like something called regolith. It's a type of stone here, I'll put it right here, regolith. It's a type of stone, it's found on the moon actually, which we'll talk about in a bit. It's called regolith. It's usually something that's mixed of meteorites, a lot of space stuff, a lot of space rocks, comets, ice. The moon is made of regolith, yeah. It's a stone usually primarily found in space. Alright, fun fact about meteorites, the biggest crater is actually here in Arizona. The biggest crater of a meteorite made is here in Arizona. It's called Barringer Crater. It's in Barringer? Well, I don't know if it's called Barringer Crater, but it's in a place called Barringer, Arizona. I have no idea where that is. I've never been to it. But yeah, interesting. So yeah, let's keep talking about space rocks with a pretty big one coming up. Alright, like we just talked about space rocks. Here's a pretty big one. It orbits us. The moon. It's a pretty big one. You see it almost all the time. It's everywhere. It's been here for like the past supposedly thousands of years. It is the Earth's only, as the scientists call it, natural satellite, if you want to be fancy. Natural satellite essentially means something that orbits the Earth, a satellite, but it's natural, so it's not man-made. And one of 3 moons in the inner solar system. We'll talk about the other 2 in a bit. So it's one of 3 moons in the inner solar system. It has no atmosphere, which means it has no sound, you don't hear a thing when you're on it, and no wind. So all the footprints and stuff and tire tracks left by rovers and footprints by the astronauts on the moon, they are still there, which to me is pretty cool. It's pretty cool that they're still there. You can go and see them, but it's kind of expensive to get up there. It's billions of dollars. So yeah, and it does not produce its own light. The way you're able to see the moon is that the sun, the light of the sun reflects off of the moon, and you're able to see it in the night sky. And like I said, it's also made of regolith, which is just kind of like one of the main stones that make up meteorites. So yeah. And also it makes waves, not as in like stadium waves where you go like that. It literally makes waves. The moon's gravity pulls on the Earth's and literally makes ocean waves. So when you go to the sun, when you go to the beach, you see the waves pulling along the surface. You can thank the moon for doing that. And that's why at night, that's why they say at night it's usually high tide, because that's when the moon comes up. And since the moon is literally directly above, it makes the waves much larger and they go much higher above the surface. So yeah, that's why the later it gets, the much bigger the waves go, the much farther they can travel. So yeah, fun fact. You ever heard of earthquakes? We have ours here. The moon also has earthquakes. It has about 1,500 per year. But instead, since these are earthquakes and that's the moon, they're called moonquakes. Try saying that, it's a cool word. Moonquakes. That's an interesting word. 1,500 per year. Yeah, it's usually caused by internal stuff, gravity. Jupiter's gravity kind of has an influence on it, but it's a little too far for that. So yeah, maybe not. It's usually more the Earth's gravity. Alright, turn number 4. This is a planet that's usually in all those space travel movies. It's probably the second most habitable one after the Earth, but it's not really habitable. The Red Planet, the god of war himself, named after the Greek god of war. Mars, or Ares. The fourth closest planet to the sun. It's kind of cold. Usually, you know the temperatures of Antarctica? That's about the average daily temperature on Mars. So pretty cold, and it gets colder, like minus 100 degrees Fahrenheit. So not the most gentle environment, but hey, somewhat habitable. Atmosphere, or the air usually around it, is carbon dioxide, so sadly we can't breathe it. But yeah, pretty cold there, about carbon dioxide air, so yeah, not that habitable. It used to be a planet with water flowing everywhere, rivers and stuff like that. Didn't have plants, it's just rocks. But now it's dead. There are just remnants of volcanoes, valleys and stuff like that. They're just dead. They don't work anymore, but they don't work anymore. They're not active anymore. So yeah, just sitting there essentially, just collecting dust and wind. It has water ice, which is essentially water in ice form. They call it water ice because in the solar system there are many forms of ice. There's methane ice, I think there's nitrogen ice, like frozen nitrogen, there's carbon dioxide ice. So just to be specific with which type of ice to talk about, water ice, or aka ice that we usually just go, like the ice that you put in your lemonade. It's usually, as you've heard it called many times, the red planet. It is called the red planet because of a chemical called iron oxide, also known as Fe2O3. I think I got that right? Yeah, okay. Iron oxide that makes, or as you guys know it probably, rust. Iron oxide is the same as rust. It makes the earth, or makes things metal, makes them corrode, makes them give them an orange-red look. The surface of Mars has iron oxide, giving it that red look. It's essentially a rusted, old, dead planet. So, yeah, that's kind of usually it of it. It has 2 moons that are shaped literally like potatoes. Like, they're like elongated like this. Phobos and Deimos, the other 2 moons that make up the inner solar system along with our moon. So yeah, there's the only 2. All the ones in the gas giants. There are hundreds of moons, which we'll all talk about. Not all of them, though. Fun fact. Olympus Mons. It's a mountain. It's called Olympus Mons, which is probably named after Mount Olympus, which is the Greek god, the Greek mountain where all the gods live. Olympus Mons is the tallest mountain on Mars and the tallest mountain on the solar system. It is the last of the terrestrial planets. It is the tallest mountain there. 3 times the height of Mount Everest. Even if you see satellite images of Mars, it peers through the atmosphere like you could see it from space, literally. It's huge. It used to be an old crater. It has craters on top of it. Volcano. I think it used to be a volcano, actually. So yeah, it is ginormous. It's 3 times the solar system. It's the tallest mountain. Yeah, we got 1 more term to go, and yeah, we wrap up the inner solar system and the first episode. So yeah, let's do the last term. Alright. Final term of episode 1 of season 5, the basics of astronomy. We're essentially going out of the planets that we know, and we're going to essentially what is the border between them? The asteroid belt. It is literally the border between the inner solar system and the outer solar system. That's what defines it. It is essentially a large ring of rocks, so you can imagine your solar system and then just the inner solar system, and then essentially a large ring surrounding that inner solar system, and then their other planets and all the ice giants and outside. So it's a large ring of rocks between Mars and Jupiter, like I said. There is actually a planet there. It is not a planet in the solar system, so don't get confused. It's called a dwarf planet, essentially what is Pluto. It's a dwarf planet called Ceres. It's pretty small. It's not like anything habitable where we can go. It's essentially just a rock, no atmosphere like the moon. And it's very small. It's a dwarf planet. It was promoted to a dwarf planet in 2006. Fun fact. Because of Jupiter's gravity, which isn't that far from it, the asteroids and the ones that are usually around the asteroid belt, they're always crashing into each other and shattering. Not as much from Mars's gravity, because that isn't as strong. That is like microscopic gravity compared to Jupiter's ginormously huge gravity. So yeah, that's where all the asteroids that are usually there get influenced by Jupiter's gravity. Of course, they orbit around the sun. Well, I don't know if they orbit, they just stay put. They just crash into each other and stuff like that. So yeah, that just tells you how big Jupiter is, how its gravity can influence something that's millions of miles away. Yeah, that is pretty interesting indeed. Some of the asteroids in the asteroid belt are considered to be something called NEA, which I'll put it here, NEA, which are also known as near-Earth asteroids. So yeah, they're near the Earth. So yeah, they're not going to usually hit it, which actually brings me to my fun fact. So fun fact about asteroid belt, a 165 foot wide NEA, or near Earth asteroid, I'm pretty sure that lives up to its name. It passes near the Earth. It strikes Earth every 1,000 years. So approximately every 1,000 years, a 165 foot asteroid called an NEA strikes the Earth, which I'm guessing that hasn't happened for 1,000 years. Yeah, it's been a while, so yeah, pretty interesting. Alright, so yeah, we finished our key terms, all 7 of our key terms for this episode, so yeah, let's move on to announcements. Alright, so yeah, that is a wrap on episode 1. We have started season 5. It's so crazy to think about that. just 3 years ago when the pandemic started in the spring. I started this series with season 1 in chemistry, and now we are 5 seasons into it. So yeah, thanks for coming along, guys, for this journey. But yeah, let's go over some announcements. The next video that will be back, we are going back to gaming, so get excited for that. Turmoil number 5, Turmoil gameplay number 5. We're going back to Turmoil. I was supposed to do it before we went to Mexico, but unfortunately I didn't have time. I had academic stuff to do. So yeah, gameplay number 5 of Turmoil coming to you on August 13th. So August 13th, Turmoil number 5. And also, I don't know if you saw, but I put a community post a while back that said that I am no longer going to be putting videos or playing F1 2021 or Surviving Mars. They don't interest me that much anymore, and videos sometimes take a bit too long to edit. So yeah, unfortunately those series will be discontinued, so that just leaves us with Turmoil, Cuphead, Stardew Valley, and Burnout Paradise. That's the last one. I might add another gaming series this year or maybe next year, maybe around the winter, maybe next year. So yeah, who knows? I'll have to see. I'm thinking of some games maybe to add. So yeah, we'll have to see about that. So yeah, next episode, season 5, episode 2, that is coming out in a little bit. I'll talk about that in the next video. We are going to talk about solar system. We are continuing our tour of the solar system. We're going to go to the gas giants next. So Jupiter, Saturn, Uranus, and Neptune. We're talking about those books and other stuff that consider in the gas giant range, so past the asteroid belt. Other things like Jupiter's moons, Europa, Titan, some cool ones, and a space probe that went there a while ago. We'll talk about that as well. So yeah, thanks for watching. Thanks for coming back for Prietology. It's great to be back. It's great to do this again. This is something I really enjoy doing, and hopefully you do as well. But yeah, I will see you in 2 weeks for Turmoil gameplay number 5. So yeah, see ya, and remote. Hello everyone, welcome back to Dprieto TV, and we are almost done with August. We are in the last week of August, but Prietology Season 5 Episode 2 is just getting started. Like I said, welcome back. Welcome back to Prietology. We are back with Season 5, Episode 2. We're back with Episode 2. The gas giant gang is what we will be talking about, the second half of the solar system. So yeah, we're excited to get into the Jupiter, Saturn, Uranus, and Neptune, and a bunch of other little miscellaneous things between all them we will talk about today. So yeah, I see no other reason to continue talking. Some quick announcements at the end. So yeah, let's start this episode and let's go over the key terms. Okay, so yeah, let's go over our key terms here in episode 2 of season 5. The gas giant gang, like I said, we're talking about the second half of the solar system, so wrong thing. We have Jupiter, Jupiter's moons, which we'll talk about. There's another name for them. Saturn, Cassini-Huygens, Titan, Uranus, and Neptune. Some interesting terms for episode 2, so yeah, let's get started. Alright, let's get this show under the road. Jupiter, our first term, the 5th closest planet to the sun, and the largest in the solar system. It is huge. It is ginormous. People don't understand. It's a ginormous gas giant. It is so big. It's unbelievably big. It's probably like a tenth of what the size of the sun is, which in sun terms is huge. It's almost made entirely of hydrogen and a little bit of helium, but mostly hydrogen, so it's this close to tripping into a star. If it was just a little bit bigger, it would be its own star, and Mars and Saturn would well, they wouldn't vaporize. Mars would be much hotter. We would be much hotter. Saturn would be much hotter as well. Uranus and Neptune. Yeah, it would have changed everything if Jupiter was a star. It was only this much off. It has 63 moons. I remember in the last episode when we were talking about Mars and Earth, them only having 1 moon with the Earth and 2 moons with Mars. This one has 63. A lot of our gas giants have a lot of moons. It has 63 moons and moonlets, which moonlets are not the moons of moons, which I thought was before this episode. But they're actually small little bits of like anything, like rocks, like a little small thing that orbit it. Not exactly like a terrestrial moon, not that big, but little moonlets. So like, let's say little asteroids that orbit it somehow, not in a ring, but just asteroids in general that go outside of the orbit of the ring. It spins, its like spin on its axis is very quick. The days on Jupiter are only 10 hours. They are much shorter than here, less than half our day here. Our day here is only 24, theirs is 10. only 10 days with it spinning, and with that spin, it creates very, 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 very high winds in the atmosphere and the cloud tops of the atmosphere that go to about 260 miles an hour, which are screaming fast. And yeah, very, very fast winds with that very, very fast spinning. As we all know, if you've seen a picture of Jupiter, like right there, that big old spot right there, that's the great red spot everyone knows about. That storm that has been there since the 1600s. A violent tornado, hurricane, just mess. It's just a mess. It's just a giant storm in the middle of it. It's about the width of 2 Earths. So it's amazing. So essentially going around the Earth once is the width of the Great Red Spot. Fun fact, it's 318 times more heavy than the Earth. It is very heavy. Like I said, it's so massive. It's unbelievably massive. It's unthinkably massive. It's this close to becoming a star, like I said. Let's move on to the next term. Alright, Jupiter's moons is our next one. We talked about Jupiter. The moons, this is where it gets interesting. The moons, when we talk about the moons of these planets, they're going to get interesting. They include the 63 moons of Jupiter, like I said last time, and are kind of like their own little mini solar system. There's so many, it's so massive. The Jupiter, like I said, acts as its own star, and it has its little moons circulating it. That's what makes Jupiter such an interesting planet, that each moon is so different from the other one. So yeah, let's talk about them. The biggest, most known ones, there are 4 that are called the Jovian moons, considering I forget what it's about, but I think, I'm trying to remember. I think Jupiter and Jovia, or Jovine, I forget the name of the Greek god, but anyway, they're called the Jovian moons. They are, let's put a list down here, Ganymede, Callisto, Europa, and Io, or Io, I don't know how you say it. So yeah, Ganymede, Io, Callisto, and Europa. Let's talk about each of them. Io is the most volcanic place in the solar system. It's like that volcano place from Star Wars, but not that volcanic. It's the most volcanic place in the solar system, due not to like volcanoes underneath or like rumbling lava or earthquakes or anything. It's actually due to friction. Yeah, imagine that. Friction. Why? Let me explain. Io's gravity, so imagine you have Io right here. Gravity around it, its own magnetic field and force field. Jupiter's gravity, on the other hand, is so massive that it just scrapes against Io and warps it, and it's under intense gravity from Jupiter, and its gravity just scrapes it and like melts it and like wobbles it around. It like compacts it and stretches it, so all the kinetic energy of it being stretched causes the rocks to heat up and eventually melt, and then lava comes out and geysers and stuff. Yeah, that is how Io is volcanic. It's under so much pressure from its gravity, from Jupiter's gravity, that just scrapes against it and it makes it volcanic. Interesting. Europa, on the other hand, is one that can actually sustain life. It's covered in solid ice, like solid water ice, but it could have life-sustaining salt water underneath all that ice. So who knows? That's maybe something for the future to find out. Ganymede, on the other hand, there's not really anything special about Ganymede other than it's the only moon with a magnetic field. Fun fact. That's actually, out of all the 63 moons, 62 of them don't. Ganymede does. So that's interesting. Callisto, on the other hand, kind of dead. In a nutshell, yeah, it's kind of dead. Just a dead planet, kind of like Mars. How it's just barren with nothing, just rocks, no atmosphere, tons of craters and cracks and everything. Yeah, dead old wrinkly planet. I mean, not planet, a moon. Fun fact. Like I said in a while back when we were going over the key terms, these moons are also called the Galilean moons. And in 1610, Galileo, with these moons, he proved that the Earth wasn't the center of the universe. With his discovery of Jupiter and the Jupiter moons, he proved that the Earth wasn't the center of the universe / the solar system. Because back then everyone thought the Earth was the center, the sun orbited it, and all the planets did. But no, sun orbits it. That is correct. Alright, next term. Alright, on to term number 3 here. We're halfway, but it's 7 terms, so this is exactly not a half. But anyway, let's talk about the most, in my opinion, my favorite planet, and the most beautiful of them all, Saturn. The ringed planet. 6th closest to the sun, but surprisingly, only has a gravity 90% more, 0.9 times the Earth's gravity. So, not that much, which is kind of surprising. It has at least 60 moons, so 60 plus moons and moonlets, like we talked about little other things that orbit it. And obviously they're still finding some, but so far we have found 60 of them, which is still a large amount for a planet. And considering it's kind of big, so yeah. Has very beautiful looking atmosphere, perfect shades of sometimes green, of blue, of a nice yellow, kind of like a tan-ish. And obviously known for its rings. Beautiful rings that surround it. But surprisingly, their rings are about, I'm going to have to say this number right, 1,550,000 miles wide. So, ginormous. But they're only 164 feet thin. So astronomically or planetarily, or in this concept of Saturn, they are incredibly thin. They are super thin compared to how big Saturn is and how wide they are, but they are incredibly thin, about 20 meters thin. And the rings are made of rocks, so like asteroids, ice, water ice, methane ice, hydrogen ice that freezes in the vacuum of space, and dust, not like dust that you find in your room or a dust bunny, like crushed up rock in the form of dust. So rock, ice, and dust make up its rings. People believe, or not people, scientists rather believe, that Saturn actually has an ocean. It's essentially under all that cloud layer and all those violent winds, which we'll talk about in a bit, has an ocean of liquid hydrogen. Of course, it's so far away from the sun, it's at a temperature where hydrogen is able to freeze, well not freeze, but go from a gas to a liquid. If you want to learn about gases and liquids, go watch season 1 of Prietology. But it's at a distance far enough so that the hydrogen in it is able to go to liquid form because it's so far. So it could just be an ocean of liquid hydrogen, like the Earth, but essentially no land. And it could have a core of solid hydrogen, yeah. There's a lot of stuff we haven't discovered about Saturn yet. That's what makes it such an interesting planet, and we'll talk about more about it later. Fun fact! The cloud tops and planets are essentially like the tops of the clouds, so like the atmospheric layer, like the air in it, so like the cloud tops, like, you know, like where the clouds are above those clouds, winds can get up to 1,243 miles an hour. Wow. Try saying this. A lot of people actually struggle to say this on the first time, but this is actually really cool, interesting. Cassini Huygens. They're actually a pair of space probes. We've talked about Saturn actually for a bit. They're a pair of space probes that went to investigate the wonders of Saturn. Cassini and Huygens. They're two different space probes, but people usually put them in the same word because they were part of the same mission. Cassini went to Saturn and went around the planet 74 times, and recently, in the past couple of years, went 20 dives between Saturn and its rings and collected a ton of information, while Huygens, who's a little smaller space probe, was sent to investigate the surface of Titan, which we'll talk about in a bit. They're the first ever probes to orbit Saturn. It studied its rings, magnetic field, atmosphere, and 7 of its moons. Very accomplished space probes. The mission ended, unfortunately, in September 15th of 2017. It was been gone for a while, and it started in 1997. So a long time ago. And yeah, let's talk about fun facts. It was named after astronomers. These two probes were named after astronomers. Giovanni Domenico Cassini and Christian Huygens Cassini discovered Cassini's gap, which is the space between Saturn and its rings. That's why Cassini, in its last couple of months of mission, it went between its rings and just studied a bunch of information. That's why it's called Cassini's gap. And Huygens discovered Titan, so it was only appropriate that Huygens got to go to Titan. So yeah, fun fact about each of those things. So yeah, let's keep talking about Saturn in a pretty interesting term. This is by far a very, very interesting planet. Saturn's largest moon, Titan, named after the Titans in Greek mythology, the weird giant beings that would torment the Earth, something like that. So yeah, second largest moon in the solar system. Ganymede is the largest moon in the solar system. Fun fact, we talked about it a while ago. So it's only 2% less than Ganymede, and bigger than Mercury. It's bigger than Mercury, even a planet. Mercury's pretty small for a planet. And it's bigger than Mercury, fun fact, and it's Saturn's largest moon with a diameter of 3,200 miles. It is huge. A 124-mile deep haze covers its surface. It's pretty huge. but it's all hazy. It's like, it's methane. It's a methane haze that covers it. It's a 124 thick, deep haze. And it's the only moon in the solar system with a permanent, you heard me say that, permanent atmosphere, covering it in a reddish methane haze. It's so thick that you could literally swim in it. Literally, like imagine swimming in a pool or in a lake. You could literally swim through the atmosphere of Titan. It is so thick. Obviously, don't breathe it because methane. You can't breathe methane. Huygens, we just talked about Huygens, we just talked about in the Cassini Huygens. Huygens reported that when it went into Titan, it has a surface, lots of craters, even sand dunes, many liquid methane lakes, and weather and seasons. Does this sound familiar? It should. It's a lot like Earth. This could be a life-sustaining planet. Huygens just scratched the surface. Well, it didn't scratch the surface. It went pretty deep underneath. But still, there's a lot about Titan that we haven't learned yet. But Huygens discovered a lot about it. Obviously, we don't have methane lakes, but we have lakes. We have some craters. We have sand dunes. We have weather. We have seasons. So Titan could be a gold mine of scientific information we haven't seen yet. Fun fact, the surface pressure, remember how I said it's so thick you could swim through it? The surface pressure on Titan would be a lot like being at the bottom of a swimming pool. That's how much the pressure is, but it can be super crushing because 124 feet of water, that's a lot. And still, it's so thick, the atmosphere, like you could literally swim in it. So just sit at the bottom, try being at the bottom of your pool and seeing how that pressure's that would be the surface. That would be the surface pressure on Titan. So yeah, 2 more terms to go. Alright, where's my marker? We are almost done with the solar system. We got 2 planets left, and then after that we're going to be going a little bit beyond the solar system in the next episode, but we'll talk about that at the end. Uranus, not Uranus. Ha ha. Uranus is how it's actually pronounced. It's the 7th closest planet to the sun. It's pretty far. 27 moons and moonlets. It's starting to decrease a little bit. Jupiter has the most, then Saturn, then Uranus, then Neptune. About an average temperature, as you know, the farther we go from the sun, the colder it gets. 346 degrees Fahrenheit average temperature, negative 346 degrees Fahrenheit average temperature. It is freezing cold, nearing absolute zero. It is absolutely freezing there. You would freeze in an instant the moment you step in Uranus, considering if you even get there in the first place. Long ago, not in a galaxy far, far away in our solar system, a collision knocked it sideways. So imagine Uranus. Where's my Uranus? It's up there, but I'm not going to get it. So let me get a sphere. Alright, I have this little glass ball. I don't know if you can see it right, but a little glass ball. Long ago, let's say it spins like this. The glass ball of Uranus spins like this, like a normal planet. But long ago, it got hit sideways, and now it's spinning like this, but now it's tilted like this, and it spins like this on its axis sideways. Because of its sideways spin, how it spins like this, the poles, or the both sides of it, face the Earth for 21 years, and then 21 years in total darkness. So do the math, a full year on Uranus is 41 Earth years. So yeah, pretty interesting. Because it only spins sideways, imagine spending 21 years in direct sunlight and then 21 years in absolute darkness with nothing. Absolutely nothing, because you're literally facing the vacuum of space where there is nothing there. On Uranus, there are very large storms, and all of these gas giants, there's lots of winds and storms. There's big storms that shoot clouds of crystalline methane, so methane in its crystal solid form, at high speeds of around 260 miles an hour. Screaming fast, shooting along the atmosphere, just like shooting along the atmosphere, 260 mile an hour clouds, imagine that, and they just rain crystalline methane. And sometimes, if it's so much pressure, because it's made of methane, it's so much pressure that it forms diamonds, because methane is carbon-based, and if the pressure is high enough, it can make diamonds. So sometimes it can literally rain diamonds, which would be pretty cool, but kind of painful, because diamonds are diamonds are very sharp, so they just go in your face and that would really hurt. Fun fact, it has rings, if you haven't never seen a picture of Uranus, so to our little model just add rings, along with 4 other planets, fun fact if you haven't seen. All the gas giants that we have rings, all of them. Jupiter, Saturn, Uranus, and Neptune. All of them have rings. That is a very interesting fact. Even Saturn obviously has rings. Jupiter's a bit smaller, a bit faint, not that easy to see. Saturn obviously has rings. Uranus, if you haven't seen it before, does have rings, but sideways like this along with a spin, much thinner. And Neptune, obviously, well not obviously, but sometimes they're visible, but not that visible, but it has very thin rings, kind of like Jupiter. Alright. Let's get to our final term, the final planet of our solar system. Alright, final term of episode 2, the farthest, the coldest, with an average temperature of 336 degrees Celsius, goes to Neptune, the farthest last planet in our solar system, with 13 moons and counting. Its pure white ammonia clouds move super quickly in the solar system atmosphere, not the solar system, its atmosphere. 1,550 miles an hour, incredibly fast, freezing cold, causing the highest ever winds in the atmosphere. I mean, in the solar system. The highest winds you can find anywhere, even faster than the screaming fast ones of Uranus, Saturn, Jupiter, Mercury, Venus, Earth, and Mars. It's faster than all of those. It's the highest in the solar system. Under the atmosphere, which is made of ammonia and methane, it has a boiling ocean of liquid methane that can create diamonds like Uranus, except Uranus's diamonds are made from the atmosphere of those ammonia, those crystal methylene clouds. Crystalline methane clouds, those ones that shoot super fast to make under pressure. Its boiling ocean of methane can make diamonds. It's the first ever planet in the solar system, the only to not be found by a telescope and an astronomer, but to be found by mathematical calculations. It was found, oh, I forget who it was founded by, but yeah, it was founded by mathematical calculations. I'm guessing they observed something was pulling gravity of something, gravitational, something should they essentially decided like, oh, there should be a planet there, so calculate it, and you find Neptune. For 20 years, a giant tornado in, I forget where, I think along its equator somewhere, called the Great Dark Spot. This sounds like another one, the Great Red Spot on Jupiter, but this one is called the Great Dark Spot. Existed in the southern hemisphere. That's where it resided for 20 years. It's gone now, compared to the Great Red Spot, which is still here after even 400 years. And with Neptune, its pal, Uranus, both of them are considered the ice giants, considering they are also part of the gas giant gang along with Jupiter and Saturn. Neptune and Uranus get a special little membership thing. They're the ice giants, the only two that we have in the solar system. Fun fact about Neptune, our final fun fact of the day, the largest moon of Neptune is called Triton, not Titan. Titan is part of Saturn. Triton is named after the son of the Greek god Poseidon, I believe so. Triton is the coldest place in the solar system, even colder than Neptune itself. It's freezing cold, the coldest place in the solar system. It's the largest moon of Neptune, and one cool thing about it is that it orbits in the opposite direction of Neptune's spin. So say Neptune is spinning this way, Triton would orbit this way. It would orbit the opposite direction of Neptune's spin. We are done. We have gone over our 7 terms, and yeah, pretty good, interesting. We finished the solar system, so yeah, let's go for announcements. Whew, what an interesting my stuff fell. What an interesting episode. That caught me off guard for a second. 7 terms, we finished the solar system. So yeah, some announcements, really quick ones. I'm thinking about introducing a new gaming series at the end of the year. It's going to be the last video before the Dprieto Christmas special, which is essentially our finale of the year. So it's the video just before that. I'm thinking of doing, I don't know honestly, it's just whatever you guys want. So if you want, you can put some comments under this video or comments under any of my videos. Or I'm going to make a community tab post after I finish editing this video that I'm doing right now. Hi, editing me. There's going to be a community tab post. If you want, I'll put that there. Shoot your ideas. Next video coming on to you on September 10th. Cuphead gameplay number 8. We are back with Cuphead, back on Inkwell Isle. We're almost done with the second isle, I believe. You haven't done it in a while. So yeah, 8th gameplay of Cuphead coming to you on September 10th. Don't forget that. Stay tuned for it. The next episode of Prietology, coming soon after Cuphead, will be about beyond our solar system. So essentially what I call the Transneptunian. Transneptunian means beyond Neptune. So just beyond Neptune. So Pluto, you're wondering, hey, what about Pluto? We haven't talked about it yet. Well, it's not part of the solar system, unfortunately. But Pluto, Halley's Comet, the Kuiper Belt, the Oort Cloud, Eris. We still have a lot of things to talk about just neighboring our solar system. Then after that, we'll start getting into galaxies, stars, constellations, black holes. Cool stuff about space that's well beyond our solar system. So yeah, that's all for next episode, episode 3. So yeah, get excited for that. But in the meantime, thank you for watching. I will see you in 2 weeks for Cuphead number 8 on September 10th. See ya. And remote. Well, hello everyone. Welcome back to Dprieto TV, and we are almost to the end of the month. Today is October 1st. Wow, what an interesting video we've got today. We've only got October, November, December, and then we're done with the year. But we still got a lot left to go in Prietology Season 5. We're on episode 3 of 8 today, talking about things that are far, far, far away, billions of miles away. Today we're talking about the Transneptunian solar system, so beyond Neptune, Pluto, and all the other gang planets that are there. Yeah, and a bunch of other space objects that are there. Yeah, it'll be pretty interesting to talk about all of those. Some announcements at the end, some pretty important announcements. I'm going to be shifting around the schedule for the rest of the year, so the videos that are coming in the next part of the year, to the end of the year, I'll be announcing all those videos, and I'll show you that it's not going to be the usual order where we usually do like a gaming, then Prietology. It's going to be a different order because I want to try to do something that not that I need to do, but I want to do. So yeah, that's going to change. So yeah, we'll talk about that at the end. But yeah, let's waste no more time and let's go over our key terms for episode 3. Alright, so I'll move over here. Yeah, we got 7 key terms here today. Remote. We got 7 key terms here today. Like I said, we're talking about the Transneptunian. So I'm not gonna be able to say that right. Transneptunian solar system beyond Neptune. So yeah, we got 3 terms today. We got 7 terms today in episode 3. We have Pluto, Eris, New Horizons, Voyagers, Kuiper Belt, Oort Cloud, and Halley's Comet. We'll be talking about all those in good depth. So yeah, let's get started. Alright, so to kick things off in our Transneptunian solar system, good old Pluto, the long lost, forgotten Pluto. Shame what happened to this planet. It used to be the 9th planet in the solar system, the farthest, the coldest. It was sadly, I don't think this should have happened, sadly demoted to a dwarf planet in 2006. So it has not been a planet for the solar system in 17 years. Yeah, 17 years it hasn't been a planet in the solar system. 5 moons, I'll list them here. We have Charon, Styx, Nix, Kerberos, and Hydra. There you go. Those are all the planets that like Styx and Nix that kind of rhyme. Speaking of planets, Pluto essentially has a twin in one of its moons. Charon is almost an identical copy of Pluto, but obviously a little bit smaller because it's a moon. It's almost essentially an identical copy of Pluto, but as a moon. Pluto has a lot of ice. Its atmosphere actually freezes when it gets much farther away. When it gets closer to the sun, so it's more of like an elliptical shape that goes. Say the solar system is straight like this, like a plane. Pluto's orbit is more like that. There you go. So when it goes closer to the sun, its atmosphere melts, and then when it gets farther away, the atmosphere essentially freezes. And I forgot what it's made out of, but its atmosphere freezes. And like I said, during that year, it only gets a bit of the sun's warmth. It only gets a bit of the sun's warmth every single year. Its average temperature yearly is negative 382 degrees Fahrenheit. It is absolutely freezing cold on Pluto. You'd freeze in an instant the moment you get there, if you're able to get there in the first place. Sometimes, like I said, it gets inside Neptune's orbit, and like I said, getting closer to the sun warms it up and lets its atmosphere unfreeze itself. It's closer to the sun for 20 years at a time. I have no idea where it is right now. There's probably an app you can find to look at the star charts. Yeah, but yeah, it gets closer to Neptune's orbit every 20 years, and it gets closer to the sun, warming it up and making that atmosphere more of a gaseous state. Fun fact, The distance from Pluto to the Sun, which, as you know, is incredibly far, 3.7 billion miles away. That is absolutely out there. It is freezing cold. It only gets a little bit of light. Yeah, but still the sun is able to warm it up from 3.7 billion miles away. That is huge. My goodness. Okay, here's another dwarf planet that's also trans-Neptunian. It's one of the, I forget how many dwarf planets are out there, but there's a good amount of them. Eris. This is not a very well-known planet. Before it was fully discovered and classified, the people thought this would be the 10th planet in the solar system, but sadly no, because NASA is weird like that. It's another dwarf planet beyond our solar system and similar to Pluto-ish, and it has one moon called Dysnomia. That sounds like some weird mystical thing. Dysnomia, which is named after the goddess of lawlessness. I have to say that fast 10 times. Lawlessness. And Eris and its moon were discovered in 2003. So happy 20-year anniversary of discovery of Eris. So yay. Mostly unknown. A lot of the things that we're going to be talking about, a lot of these celestial objects are mostly unknown. We don't know much about what's beyond our solar system because it takes a long time to get there. We'll actually talk about one of those that took a long time to get there. Mostly unknown planet. It's the largest of our new group of planets, new group of exoplanets, dwarf planets, one of the largest. And Eris is named after the Greek goddess of strife and discord. So essentially chaos, of messiness, of discord and strife. Yeah, chaos rules on this dwarf planet, I guess. Before it was called Eris, named after the goddess of strife and discord, it used to be called 2003 UB13. UB313. There you go. So Eris used to be called 2003 UB313. It also has other names that we've called it on Earth, called Xena, 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 or Xena, and Planet X. If you ever heard of that before, they're talking about Eris. Fun fact, one Eris year, so one time it takes to orbit around the sun, and yes, Eris still orbits around the sun even though it's super far away. One Eris year is equal to 205,000 Earth days. So 205,000 days on our Earth is one Eris year. So yeah, so I don't want to do the math right now of how many years that is. Actually, let me do it really quick. Alexa.
205,000 divided by 365 is approximately 561.6438.
So 561.6 years, Earth years, it takes for Eris to orbit the sun. So it is super far away, much farther than Pluto ever is. Okay, found my marker. This is one I was talking about when we were talking about Eris, of things that have also been beyond there that can go pretty fast and discover these. New Horizons. It's a much newer spacecraft that actually was launched recently, and its whole plan, its whole mission, its whole goal was to photograph Pluto for the first time ever and visit the Kuiper Belt. KBI shortened it. We'll talk about the Kuiper Belt in a bit. But yeah, it was it's not a manned spacecraft, but it was a spacecraft planned to visit Pluto and the Kuiper Belt and other objects and photograph it for the first time. New Horizons is about the size of a grand piano. So if you've ever seen a grand piano, one of those concert halls, New Horizons about the size of that. One cool thing that's about New Horizons is its speed. That is what makes it much more different than any other spacecraft you know. Fastest ever launched. 36,258 miles an hour leaving our atmosphere and going off into space, and it is still traveling incredibly fast through the atmosphere. It has already reached Pluto. It reached Pluto in 2015, more specifically July 14th of 2015. I remember when I was, how old was I in 2015? I don't know. When 2015, I remember we were in Mexico on our usual vacation, our family vacation that we take there to visit family. I remember seeing on the news that morning, just like, hey, this New Horizons spacecraft encountered Pluto. This is the photograph that they sent on the news at, oh my goodness, Pluto in all its glory. Yeah, that was the first photograph image of Pluto. It looks much more pink than it usually does in images or in predictions of what it would look like. But yeah, alright, fun fact about New Horizons. The guy who discovered Pluto, his name was Clyde Tombaugh. He obviously is dead by now. So, what New Horizons and NASA did is that they took some of the ashes of Mr. Tombaugh, the discoverer of Pluto, they put it in the spacecraft, and they took it. New Horizons, currently, right now, past Pluto, has ashes of Clyde Tombaugh, the discoverer of Pluto, on it. That's kind of cool. Imagine like discovering a planet and then dying and then having yourself literally taken to that planet that you discovered. It's like you're sent super far to go discover that planet. It's amazingly cool. Yeah. Whew. All right. We got 4 more turns to go. All right. This is probably one of my favorite space probes. After Cassini, this is probably one of my favorite space probes. And considering emphasis on the word space probes, plural, the Voyager probes, a classic of space exploration. They're a pair of old space probes launched in 1977 and are still working. 46-year mission. They have been in space for a long time. Yeah, they're still going to this day. A pair of old space probes, like I said, launched in 77. They have visited the most amount of planets and moons than any other spacecraft, not combined, but most of any other spacecraft, both of them. After seeing Jupiter and Saturn, essentially, I think Voyager 2 was launched first and then Voyager 1, I believe. So yeah, after seeing both Jupiter and Saturn and taking tons of photographs of them, Voyager 1 took a sharp left and went up into outer space just to explore, and after that. And Voyager 2 essentially went on a tour of all the gas giants and is going very, very far. They're already super far, the farthest man-made objects ever made. And went to see Jupiter, Saturn, Uranus, and Neptune, took amazing photographs, amazing exploration, amazing data collected of all the moons, planets, asteroids, the Kuiper Belt, which we'll talk about in a bit. It went past, it didn't get to Pluto, it didn't photograph Pluto, but then it went past and it's off into space, and they're both going in different directions. Yeah, they have a massive legacy, massive history, very, very accomplished space probes. They have seen the most things in the solar system than any other space probe before. Starting in 2020, they started to lose power, but scientists actually thought that they lost signal in 2020 with one of the Voyager probes. It's like, oh, it's dead, but somehow it's back. It's back from the dead. It's supposedly this loss of signal, it just turned off and they just turned it on again, and Voyager's back. Yeah. They're still going to this day. Obviously, they're much older. They don't have the same amount of technology. They're losing power because they're very old. So yeah. And fun fact about, well, not the fun fact, but it takes 14 hours for a signal from either of them to reach the Earth, especially Voyager 2 since it's closer. It takes about 14 hours for the signal to reach Earth. That is incredibly, so it's traveling at, it takes 14 light hours for 14 hours for the speed of light from the spacecraft to reach Earth. Yeah, super, super far. Fun fact, speaking of the Voyagers, Voyager 2, which is probably the most known one, showed that our solar system is more of an ellipse, not a circle. If you don't know what an ellipse is, an oval, essentially. It's not that much of like a, what was the analogy they used? It's not so much like a circle, it's more, they said, like a football, like this. It's more of a football elliptical shape than your traditional circle. So, yeah, let's move on. We got 3 more terms to go. We mentioned this when we, which one did we talk about? Ah, yes, when we talked about New Horizons. The Kuiper Belt. It's essentially like the asteroid belt, but much, much farther. It's a belt starting at Neptune's orbit, so past Neptune, and is 20 times wider than the asteroid belt. It is huge. It is made of just rock and ice and dust. It is freezing cold, and essentially some scientists consider just like a sharp fence, a sharp perimeter of super razor sharp rocks, super razor sharp ice of asteroids just surrounding it as a belt. And I don't think they move. I think they just sit there, essentially. It's a giant ring past Neptune, and so it's Neptune, Kuiper Belt, and then everything else beyond the solar system. Largest known members of the Kuiper Belt are Pluto and Eris. Oh, that's 3. Pluto, Eris, and, oh, I guess you can lump Charon in there, which is essentially kind of like its own thing. But yeah, those are the largest members of the Kuiper Belt, and essentially they are, like I said, they're members of the Kuiper Belt, largest objects there. And like I said, they are freezing cold. I'm telling you, this is barren wasteland. This is super cold stuff made of sharp rocks and ice. It's a hostile environment. It's freezing cold, super far away from the sun. Yeah, not that hospitable, the Kuiper Belt. And yes, it's pronounced Kuiper. It's pronounced like you say viper, but with like a K. It's spelled Kuiper, Kuiper. The more larger and rounder objects in the Kuiper Belt, those are called Plutoids. Yeah, Plutoids. Plutoids, named after Pluto. Pluto and Eris are Plutoids. They are the more larger and rounder objects, the ones that can, I think those are the ones that move more. And sometimes I think that Kuiper Belt can spawn comets like every now and then. Halley's Comet, which we'll talk about, is not from the Kuiper Belt. So yeah. Fun fact, more than 100,000 objects make up the Kuiper Belt, including both Pluto and Eris, which are Plutoids in the Kuiper Belt. More than 100,000 things make it up. It is super huge. It's ginormous. It's unbelievable. It's unthinkably huge. So yeah, we're almost done. Whenever I look at astronomy, I just always love saying this word. Oort, or Oort. I think it's more Oort. The Oort cloud. It's a weird, funny name sounding cloud. It's not literally like a cloud like you see in the sky. It's a spherical cloud in space where long period comets essentially just hang out, and it's around the entire edge of the solar system. So that's why we have so many comets. So yeah, it's essentially on the edge of the solar system. We are in the Oort cloud right now. It's 1,000 times farther than the Kuiper Belt. So the edge of the Oort cloud, the Kuiper Belt, we said, is already super huge and super far, going now 1,000 times farther than the Kuiper Belt. So the Oort cloud is ginormous. When I say the comets hang out there, a lot of our long period comets that we know, which we'll talk about next term, a lot of the comets that we have, a lot of the meteor showers that we have, those come from the Oort cloud. We're essentially in a big cloud of comets whizzing around everywhere. And yeah, when we look at it, when we look at the Oort cloud on telescopes, it's very dark, it's very black, it's hard to see in the super dark night sky, and it is absolutely freezing cold, which we'll talk about in a bit what happens when they get heated up. So yeah, super black, super cold when they get in the imaging of the telescope, because it's super cold, and like I said, dark space, dark image. In deep space, the balls of rock and ice, they just sit there. They don't whiz around until they get closer to the sun. When they get closer to the sun, past usually Jupiter's when you can really start feeling the effect of comets, they start to form into comets, which means they start speeding up, they get impacted by the sun's gravity, they form those tails. Have you seen those tails of, oh, I thought I had a comet around here, but I don't on my night sky. But they form a tail of essentially like balls and of snow. It's essentially just like a snowball. It's a ball of rock and ice, and it gets melted and just, it forms like a tail of fire. Well, not a fire, but essentially like burning hot ice, and it just whizzes through. It's pulled in by the Earth's gravity, and sometimes there's a slingshot effect where it goes around the sun and it gets slinged across the other side and it goes out into space. So yeah, that's the Oort cloud. Fun fact about the Oort cloud, the width from one edge of the Oort cloud to the other edge of the Oort cloud is 1.6 light years. It takes light 1.6 years, so over 1.5 years, to go from one side of the Oort cloud to the other. So if you were light and you were starting at one side of the Oort cloud on August of 2022 last year, you would get to the other side of the Oort cloud by the end of this year, around New Year's. So yeah, not maybe New Year's, around like January, February-ish, yeah, of next year. Yeah, the Oort cloud is massive. We got one more term to go, and it's pretty interesting. It actually relates to the Oort cloud. Alright, this is an interesting last term. It's one that you may be able to see in the future. Halley's Comet. I forget who it's named after. Hold on. I'm looking at the astronomy book that we have. Well, technically it wasn't created, but its orbit was predicted by Edmund Halley in 1758. So, named after Halley. Edmund Halley, and makes Halley's Comet. It's a peanut-shaped comet. It's shaped like a peanut that visits the Earth, or a periodic comet, and it visits the Earth every 75-ish years, 75, 76 years. The last time it visited the Earth was 1986. So ask your parents if they saw Halley's Comet. And the next time Halley's Comet will come around is the year 2061. So mark your calendars for that day, because this is a once-in-a-lifetime opportunity to see this thing. You don't want to miss it. Trust me, I have marked my calendar for so many years now from now on, so almost 70 years from now on. I would love to see this comet from 50 years from now, or 47 years from now, to see Halley's Comet. Mark your calendars. Do not miss this opportunity to see something that very few people have seen before. Where were we? It's essentially, it's a very big comet. It's a spectacular looking one that from people have seen. It has a giant tail. Remember how we were talking about tails, comet tails in the Oort cloud? It's a giant tail that goes 60 miles long. It is huge, and the debris left in its wake, or when it passes by, it causes 2 meteor showers per year. So our annual meteor showers, they are caused, well, some of our annual meteor showers are caused by Halley's Comet. And with it orbiting, with it passing every single year, that means it's trapped in an endless spin around the sun, and we're only able to see it for a short amount of time. Oh, how long does Halley's Comet say? I forget. But essentially it's trapped in an endless orbit around the sun, pulled in by the sun's gravity. It'll forever keep going like that until it essentially dies, or it blows up, or it erodes into nothing. But yeah, it has been visited by 4 space probes. I'll tell you which ones. Vega 1 and Vega 2, which essentially counts as like one space probe group. Giotto, which I'm guessing is the Italian one. Suisei and Sakigake. Those are the space probes that have visited Halley's Comet, and they've actually landed on it and essentially take samples and bring them back to Earth. Fun fact, this is actually a really interesting fun fact. Listen to this. It has been seen, actually, it has been documented much before. This has been seen in history before by people who lived 1,000 years ago. Ever heard of William the Conqueror? During the Battle of Hastings in 1066, William Conqueror was about to go into battle, and he saw the comet in the sky, and essentially he's like, oh, good luck. So Halley's Comet passed by in 1066. It was a sign of luck and good hope for William the Conqueror just before the Battle of Hastings, before he met King Harold, and he eventually defeated him. William the Conqueror won the Battle of Hastings, and yeah, history goes on after that. So yeah, this might be a sign of good luck for you. Who knows? Well, we have finished our episode, so yeah, let's go over some announcements. We got some very important ones to talk about. So yeah, let's go to announcements. Football, back up here. Kind of short, but anyway, football's back up there. We have finished episode 3. We got 5 episodes left in this season, and that's the end of Prietology for good. But yeah, let's enjoy it while we have it. Let's stop and smell the roses. Is that what they say? Yeah, just stop by and enjoy the moment. Alright, announcement. This is very important, so listen carefully. For the next rest of the year, I've actually decided to flip around the schedule just a little bit of which videos were coming out. There will be 1, 2, 3, 4, 5, 6, 7 more videos coming out this year, and that's it. We're in 2023. I know it's happening so fast. So, October 15th, which is our next video, we'll be playing Burnout Paradise for the 3rd time. That's going to be interesting. Burnout Paradise number 3 coming out on October 15th. And then, October 29th, which I think is 2 weeks after, will be Cuphead number 9. We're going to play Cuphead again. I want to beat that dragon level. I just want to get done with it before the end of the year so we can go into 2024 with getting into Isle 3. So yeah, we're going to play Cuphead again just to beat that level, just to move on. It's irritating me. So yeah, October 29th will be Cuphead number 9. Then, 2 weeks later? Yes, 2 weeks later, Prietology Season 5, Episode 4. We get to do this again on November 12th. That will be Season 5, Episode 4, coming out on November 12th. Then, November 25th, the Sunday after Thanksgiving, will be Prietology Season 4, Episode 5. So those are kind of a back-to-back thing. So we'll have back-to-back episodes. Get excited for that. Prietology Season 5, Episode 5, coming to you on November 26th. Then, on December 10th, Stardew Valley number 3. We're playing it for the 3rd time this year. I'll try to play it more often next year. We didn't really get to play it that much this year because of other stuff I wanted to try. So yeah, December 10th, Stardew Valley number 3. December 17th, the last video before the Christmas special, Prietology Season 5, Episode 6. So after we got 3 more episodes that we're doing this year, Prietology, Season 5, Episode 6 will be coming out on December 17th. And then, Christmas Eve, December 24th, is the Dprieto Christmas Special of 2024. Which, this year, I want to try to mix it up. I'm going to try to do something different. We've kind of done the same thing for the past 2 years. So yeah, I'm going to try to mix it up this year and see what we can do that's kind of interesting. So yeah, I got 2 months to think about it. So yeah, there you have our videos. So yeah, that's the videos for the end of the year. And yeah, next year, I'm a senior right now in high school. I graduate next year, so yeah, it's going to be an important step. It's going to be a big thing. I'll maybe make a video on it. So yeah, that's it. That's Prietology for today. I will see you in 2 weeks for October 15th for Burnout Paradise number 3. Thank you for watching, and like I said, 2 weeks, Burnout Paradise number 3. See ya, and remote. Well, hello everyone. Welcome back to Dprieto TV, and welcome back to November. We are almost about halfway through November, but more importantly, welcome back to Prietology Season 5, Episode 4. We're actually, now that I realize it, we're at the halfway point. So yeah, halfway through Season 5, we are coming on a roll. We are continuing to roll on with the season. I forgot to mention the topic last time, so apologies for that. We were so focused on the schedule for the rest of the year, was tweaked a bit. But yeah, today we're talking about stars, more specifically about stars, the beginning, the birth of stars, how they're created, and what their life is like, what their cycle's like. Next episode, well actually I won't reveal next episode, that's usually at the end. But yeah, so yeah, we're talking about stars today, more about the birth of stars. Yeah, and at the end of the video, I am going to announce the little game that we are playing in December. I've been hiding it for a couple months now. But yeah, we are playing a bonus game in December. Get excited for that, coming to you, I think, on the 10th of December. So yeah, get excited for that as we head into the holiday season. So yeah, I'll waste no more time talking. So yeah, let's go over our rising star terms. Alright, so we got a good amount of terms for today. I'll head over here. So yeah, we got 8 terms today. We got a bit of a loaded episode, and I think next time we also have 8 terms as well. So yeah, we're going to be talking about stars a lot. We're done with talking about our solar system and everything that surrounds it. We're now going light years, billions and millions of light years out. Yeah, we have constellations, star-birth nebulas, open clusters, brown dwarf, red dwarf, Alpha Centauri, extrasolar planets, and supergiants. Oh, it didn't fall this time. But yeah, we got a good episode today, so yeah, let's get into the first term. Where's the remote? Alright, term number 1, probably the simplest term of what we'll talk about today. Yeah, things that you can see in the night sky, they depend on where you are in the world and what time of the year you're seeing them. Constellations. Constellations are patterns formed by stars in the night sky. Like I said, can be seen at different times of the year, different places, and all of them mean different things. Yeah, constellations are cool. There's hundreds of them. There's a ton of them all over the world. But yeah, they also align with zodiacs and stuff like that. You know some constellations. You have Virgo, you have Gemini, you have Scorpio, you have Aquarius, you have Pisces, you have Taurus, you have Aries, Cancer, Leo. That's as much as I remember. I don't know the other ones. Oh, Ursa Minor, the Big Dipper is a constellation. I'm trying to think of other miscellaneous constellations. Ursa Minor, or the Little Bear, is also a constellation. There's a ton of them, like I said. So the brightest star in a constellation out of all of them, there's one main star that is the brightest out of those patterns. It's called the Alpha Star. The Alpha Star is the brightest star in a constellation, is one that makes the pattern. The pattern of stars is essentially if you would draw a line through a star, and here, let me put a picture. This is a star chart. If you put line through this star, if you put line through these stars, you can make figures, and each of these figures have their own mythology and stuff like that. They're associated with some of the Greek myths. But like I said, there's different animals. They can be named after animals, people, things, literal physical things, and each have their own unique name. Smaller patterns inside constellations, those are called asterisms. So, Big Dipper is an asterism. It's not part of, here, let's put Ursa Major. That is the constellation of Ursa Major. It's not the entirety, but you can remember, but you know it has the legs right there, but you have the Big Dipper is the main part of the bear. So, the Big Dipper is an asterism. It's not itself a constellation, but it's part of the larger constellation that is Ursa Major, which means the Big Bear. Fun fact, the largest constellation, let's put more images, Hydra is the largest constellation. It's the serpent, I believe, or a snake. And then the smallest one is Crux, or Crux, C-U-R-X. It's Latin for cross, like a holy cross. That is the smallest constellation there is in the night sky. Alright, term number 2, star-birth nebulas. This is the term that we are going to be circling literally around today. We are going to be talking about this term a lot. A lot of these other terms that are associated with star cluster nebulas, or I'll call them SBNs. Pay attention, this is an important term. They can stay there for almost 100 billion years before leaving their starburst nebulas, and they just sit there, and then I'll talk about in a little bit with open clusters of how they leave it. So they are made of hydrogen and helium, which most all stars are made out of. Like they said, they're made of our usual elements with other heavy metals like iron and nickel. Those are the other big elements that they're made of. A lot of stars, obviously, they make iron. So that's what a lot of them are made out of. And making these starburst nebulas and these stars, sometimes 1,000 times more massive than the sun. It can be absolutely ginormous. These are large galactic objects, large planetary, well not planetary, but large objects in space that are light years across. They are ginormous. So how stars are created in these starburst nebulas? Okay, let's say we have a ball of gas, a swirling ball of gas. So essentially these swirling balls of gas is when a large mass passes by these starburst nebulas, like let's say a supernova or a supergiant, which we'll talk about. So when one of these large masses passes by our starburst nebulas, they make swirling balls of gas, and the balls of gas get bigger and bigger and bigger and bigger and bigger and bigger until they literally collapse on their own gravity and create just explode. But not like a supernova. They just explode and create a star. That is exactly how stars are born, or a rough estimation of it. So yeah, balls of gas of hydrogen and helium forming together, and then it collapses on its own gravity, and you got a star. Billions and billions, well, hundreds and thousands of degrees hot. The brightest SBN, fun fact, our brightest starburst nebula that exists is called the Orion Nebula, which is another one of our constellations. It's one of the big known ones, the Orion the Hunter, I believe. Orion the Hunter. So yeah, Orion is the biggest starburst nebula, and yeah, that's where most of our stars are created. Alright, open cluster time. This also relates to our starburst nebula term. Open clusters are young stars, or starlets is what the professional term is. Starlets that are collected in groups inside our SBNs, or starburst nebulas. That's what open clusters are, young stars that are just recently formed, that are in those starburst nebulas before leaving. Let's talk about how they leave. First of all, they can be all made at one time, which is pretty cool. These starlets, and they can make different sizes from supergiants, which we're going to talk about, or brown dwarfs, which we'll also talk about. They're essentially the two ends of the spectrum when it comes to size. They can also, with these stars, they can also destroy each other's stars. So it's kind of like a bit of a brawling competition of who wants to get out, who wants to go out and survive in these SBNs. So yeah, they can even really destroy others with like X-rays. Like literally, they could just like, some of these supergiants that just blast X-rays in every single direction. They can destroy other stars in the process, or they can literally use gas. So like the flames and the gas, the hydrogen and helium blasting out of the different stars they can destroy other stars with, is essentially like a blowtorch. What these gases that come from things like supergiants come out of. So the remnants of all this chaos and happening and all this stuff inside starburst nebulas, when they all leave, smaller stars. So some of the supergiants survive, some of the brown dwarfs survive, but all these stars that come out, they all have new solar wind, which means breath of fresh air. They have, essentially, they're able to react and able to like let out all their hydrogen and helium safely and cleanly. Essentially, they have like a new atmosphere, essentially. They have fresher wind. They're out of the starburst nebula, so they're able to produce more, have their own empty spaces. They're void. The void of space is all theirs. Fun fact, the most famous open cluster in the entire universe is the Pleiades. P-L-E-I-A-D-E-S. Pleiades cluster. Or the Seven Sisters is what it's called. I'm guessing this is Greek. The Seven Sisters, which is an open cluster that is the most known in the universe. Brown dwarfs. Little brown dwarfs. Poor guys. Brown dwarfs, also relating to starburst nebulas, essentially a dim, failed, broken star. Essentially, it's super dim. It's essentially failed. It's big, super giant creation. They're broken stars that essentially don't have enough mass to shine brightly. So this is a brown dwarf. They, as you can see, they don't shine that brightly. They're really hard to see, considering the space is black. It's super dark. And these do not have enough light, mass, enough reactions to shine brightly. So yeah, they just sit there all dim in the vacuum of space. Like I said, they're essentially the remnants, they're the outcasts, they're like the waste, the byproducts of these starburst nebulas when they start spitting out stars. Like I said, remember, it's like a brawling match, and then they spit out stars, they spit out supergiants and red dwarfs and yellow dwarfs and brown dwarfs and alpha stars. Yeah, there's a ton of things that get spit out from these SBNs, from these starburst nebulas. Brown dwarfs is one of them, essentially the remnants of all that reaction and fighting in there. They're the remnants of it. They do not have enough heat along with their size. They do not have enough heat to even create nuclear reactions, which are essentially the essential part of a star. That's what gives them that's what sees your solar flares that occur on stars. All of that stuff created by nuclear reactions inside its core with atoms colliding and stuff like that. They're so small, so powerless that they can't even do basic nuclear reactions that other stars can. But they do have a bit of a size advantage compared to our planets. It's about 20 to 80 times heavier, depending on the size, than Jupiter. So a bit of a size difference compared to us. They're not microscopic, but they're smaller than your everyday star like Saturn. Or not Saturn, the Sun, rather. Saturn's not a star. And sometimes, if they get lucky enough, they can sometimes cause some nearby stars to shake. So they have some gravitational pattern. They can, if they pass by a star when getting spit out of the starburst nebula, they can pass by stars, they can shake them a little bit, cause a little wiggle, but nothing too severe like something a supergiant would. Fun facts: Teide, or T-E-I-D-E, Teide 1 was discovered in 1995, was the first brown dwarf to be discovered, and yeah, we've known them ever since. 2 years will be the 30-year discovery of the brown dwarf, so happy 28th birthday for the brown dwarf discovery. So yeah, Teide 1, first brown dwarf ever discovered. These guys live a sad, sad life in this universe. Red dwarfs, they are also a type of star. They sound kind of familiar, right? Brown dwarfs, red dwarfs, they're somewhat related. It's a starlet, remember? A young star that's spit out by one of these starburst nebulas. It's a starlet that weighs approximately, usually, under 50, just under half of the sun's mass, so they're not super small like dwarf stars, but they're not that big either, just under 50% of the mass, and they're usually too dim to see with the naked eye. So this is a red dwarf. This is a red dwarf star. Pretty interesting. Yeah, so yeah, they're not super big stars, not like supergiants, which you've heard of been talking about supergiants a lot. Yeah, we'll talk about them in a bit. But yeah, they're not the biggest star out there, but they are the most common star out there. Most of the stars in our universe, in our galaxy, are red dwarf stars. The Milky Way's mass, our galaxy that we live in, is the most common star. This makes up a lot of the mass of the Milky Way. This is a pretty common star. And most of our known stars that we know, many of the known stars that we are, the Sun is not a red dwarf. But most of the known stars, like Proxima Centauri, which we'll talk about next term, is a red dwarf. Gliese 581 is a red dwarf. You've been hearing that a lot because of the chance of life, which we'll talk about also in a little bit. So yeah, red dwarfs, not that easy to miss here in our galaxy, and really in the universe overall. They're the ones that are spit out mostly from our starburst nebulas. Fun fact, a red dwarf, like I said, named Gliese 581, this is kind of going back to what I said about Gliese 581. There's a red dwarf named Gliese 581, and it is currently being orbited by an exoplanet, which we'll actually also talk about in a bit. Sheesh, a lot of references to red dwarfs. I'm telling you, they're just so common, they could just be found anywhere in this galaxy. But yeah, it could be possibly orbited by an Earth-like planet. It's in, I won't spoil that much because we're about to talk about it, but yeah, Gliese 581, it's orbited by an Earth-like planet. It could host life. Who knows? We'll have to see. We'll have to see if technology can get us this far to even get to Proxima Centauri, which we'll also talk about in the next term. But yeah, alright. We mentioned this a lot when we talk about red dwarfs because this is a very, very, very good example of a red dwarf. Good old Alpha Centauri. You've probably heard about this in all those sci-fi shows everywhere. This place actually exists. Alpha Centauri is the closest group of stars to the sun, to us. It is 4.2 light years away, which in astronomical terms, considering something like all the other stars and galaxies in our planet, it's pretty close. 4.2 light years. It only takes light 4 years to get there. So let's say from Earth, let's say from Earth, let's say a beam of Earth that reflected off from the sun left our Earth on January 1st of 2020, it would get to Alpha Centauri it would make it to Alpha Centauri in February, mid to late February of next year. So yeah, that just tells you how far Alpha Centauri is. It is very far, but in astronomical terms, it's the closest we can get. It's made up of, like, remember how it says here, the closest stars to the sun? That is important. It is made up of actually 3 stars. It's not 3 stars into one big star. No, it's 3 separate stars, 2 of which are yellow dwarfs like our sun. They are called Alpha Centauri A and B. Those are the 2 stars. And the 3rd star is a smaller red dwarf, which we just talked about. Proxima Centauri, we just literally talked about it. It's a red dwarf, so you got our 2 yellow dwarfs of Alpha Centauri A and B, and our red dwarf of Proxima Centauri. So kind of like that Latin, has that little bit of a Latin vibe. Well, not vibe, but they're named after Latin things like Alpha Centauri, Proxima Centauri. Those are all Latin words. The light of these stars make it the 3rd brightest star in the night sky. Not planet, because some planets go pretty brightly, but star, just stars in general. It makes it the 3rd brightest star in the night sky. I think number 1 is Betelgeuse. Number 1 is obviously the sun, obviously super bright. It's the thing that provides us all our light. Number 2, I think, is Betelgeuse, and number 3 is Alpha Centauri, I believe. But yeah, all these 3 stars together, they make Alpha Centauri. And remember what we were talking about on Proxima Centauri, it could host life. Fun fact, it would take a space probe with our current technology that we have, or the technology when the book was written. It'll take a space probe about 70,000 years to get there. So yeah, we can't get there right now. We don't have the technology to do that, but who knows? In the future, we might be able to whittle down 70,000 years to maybe a year. Who knows? But yeah, as it stands right now, it would take us 70,000 years to reach Alpha Centauri. So yeah, something for the near future. All right, we are on our penultimate turn. We are almost done with the first half of Prietology Season 5. We're blasting off into space with this episode. Yeah, speaking of space, let's talk about more space terms. Extrasolar planets, or as you might know them, exoplanets. They are planets that belong to far-flung stars, far away from their star-birth nebulas. They are very, very far. Exoplanets, those are the stars, those are the planets that belong to them. The main target for astronomical research are these exoplanets because they could host life. Who knows? We might just get lucky one day when looking at a star and we see that there is life. So, something for the future that might be very exciting. So yeah, this can be seen usually when a star gets dim. So, let me see if I can whittle this down. So, you have a star. Here on Earth, we have computers that measure the brightness of stars, and usually you would expect that brightness of that star to stay at a constant unless there's like a solar flare and it gets brighter, but that usually doesn't happen. So we track the brightness of these stars, and when we see even the smallest of objects, even things that are the fraction of the size of that star, pass through them, it has to get a little bit dimmer because of the light getting in there. So there's a little bit less light. These computers that we have can track that, and if the light gets dim, that means there could be an extrasolar planet passing by it, and voila! We found the extrasolar planet. So yeah, that's good when this happens. Gliese, we're back to Gliese, or our brown dwarf. Gliese 581d is the planet, is the extrasolar planet that orbits Gliese 581. It's an exoplanet orbiting that red dwarf in Alpha Centauri. So, do you see how these things all interact? They do. It orbits the red dwarf of Gliese 581 and is located, which is the most exciting bit of why we want to find this Gliese 581, is that it's in the Goldilocks zone of that red dwarf, which means not too hot or not too cold. Does that sound familiar? It should. That's where our Earth is compared to the sun. It's neither too hot like Venus or too cold like Mars. It's right in the middle where we can get the exact amount of warmth and it can sustain life. Fun fact, there are over 300 known exoplanets in our universe that we know. Some of them are very, very, very far. But yeah, great stuff to know that we are maybe not be alone in this universe. Alright, last but not least, holy mackerel, what a term we have. Probably the biggest, literally the biggest term we've ever talked about in Prietology. Super giants. They are the largest stars in the universe. They are ginormous stars, chock full with energy, nuclear reactions, and solar flares. The largest star that can be made from a starburst nebula. They either burn red, white, or blue. Sometimes they can be a bit of shade of red, like yellowy. Our sun is not a star supergiant, otherwise we would all burn to a crisp. But yeah, it's the largest star that can be made from a starburst nebula. They can either be red, white, or blue. Sometimes blue, that means it burns hotter than a red. But the size of it is unparalleled in our universe. It is so big, 10 to 70 times more massive than the sun, with sometimes there's something called super heavy supergiant. So these are the big boys that you can see here. Very, 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 very big. They are ginormous. They can be up to 500 times bigger than our sun and burn 1,000 times brighter. That just tells you the scope of these supergiants compared to our sun. Our sun is nothing compared to the size of these supergiants. It is huge. Ginormous nuclear reactions occur in these supergiants that can cause radioactive solar winds, just super radioactive solar winds, much bigger than ours, and can cause, but with all this energy and all this size, supergiants unfortunately live small sizes, so small lives rather. They live very short lives. So yeah, that is the cost of being so big and so massive. You use up a ton of energy that goes away like that. And when these supergiants explode, or when any star explodes after the light, they just collapse in on something, gets bigger and bigger, and then just it literally blows up. And that is something called a supernova, which, sneak peek for our next episode, we're not going to talk about too much of them because I don't want to spoil next episode. So yeah, we'll leave it there with supernovas. The largest known supergiant, fun fact, is Betelgeuse. Not as in like the movie, but there's a star. It's spelled Betelgeuse. Betelgeuse is our biggest supergiant that we know. It is ginormous. What an episode. We've just finished 8 terms. Whew, that was tiring. But yeah, let's go over our announcements. We got some good announcements today. I just gotta put my toad here, my little toad cutout right here in front of our astronomy book. And yeah, let's get ready for announcements. We got some interesting announcements after what was a pretty interesting episode about stars. So, announcements coming on December 10th, which is the next video after, it's the second to next video, so it's one more video, then this new game, which will be coming on December 10th, which will be an old game. It's not a recently new one. Pac-Man Championship Edition DX. It's a game I've played before. I haven't played in a long time. So yeah, this was a game I used to play as a kid. I think you'll like it. It's an old version of Pac-Man, so yeah, it's a pretty interesting one. So yeah, get excited for that. Coming to you on December 10th, just in time for the holidays. So yeah, get excited for that. Next episode of Prietology will be Season 5, Episode 5, and then after that will be 3 more episodes. We're getting all the way to Episode 8, the longest ever season. Of course, this is our last ever season of Prietology, the last time we'll make this. So yeah, Season 5, Episode 5 will be released on November 26th, just after Thanksgiving. So first, have a happy Thanksgiving soon, in about 2 weeks. But yeah, I hope you will have a happy Thanksgiving. November 26th, stay tuned after that for Thanksgiving. You'll have your Prietology Season 5, Episode 5, which will be about more stars. We're going to continue talking about stars, but remember how I was talking about supergiants, supernovas. That is the big talking point. And what happens when these stars explode? What happens when these stars explode? More stars we'll talk about, more interesting stars that we'll talk about. What happens when these stars explode? What happens when they become nebulas? And, even in a worst case scenario, what happens when these stars are so big they can create black holes? Which, we're talking about black holes next week. Don't miss it. It's super interesting. But yeah, thank you for watching, everyone. I will see you in 2 weeks, which is going to be back-to-back Prietology lessons. So yeah, get excited. We got some interesting things this November. So yeah, thanks for watching. See ya. And remote. Well, hello everyone. Welcome back to Dprieto TV, and happy Thanksgiving weekend. I hope you had a fantastic Thanksgiving if you're watching this in the United States. But yeah, hope you had an amazing Thanksgiving. We are back with Prietology, back-to-back episodes for the first time in what seems like a long time. We haven't done back-to-back Prietology episodes in a long time, but yeah, we are continuing talking about stars. Like I said last time, we talked about the beginning of stars and how they're born. This time we'll talk about what happens near the end of their lives, not just when they die, but the whole process of how they get to the end of their lives. Get excited for this. A stellar explosion is imminent for today, so yeah. Let's waste no more time, and yeah, let's go over key terms. And we got some announcements at the end. Alright, we got the same amount of terms as we had last week. We got 8 terms. And like I said, we're talking about the stars at the end of their life, and specifically, I mentioned a word called supernovas last time. Right here. So along with supernovas in our stellar explosion today, Sirius, Betelgeuse, Cat's Eye Nebula, White Dwarf, Supernova, Neutron Star, Black Hole, and Supernova Remnants. So yeah, let's waste no more time. Let us begin. Alright, first term. So along with talking about what happens at the end of the life of the stars, we get to talk about 2 more stars that are interesting, plus a nebula that is also interesting as well. So yeah, here's another star that's out there somewhere in the universe. Well, we know where it is. Sirius. It is the brightest star in the night sky. It's known as the Dog Star, and is located in the constellation Canis Major, which is the big dog. There's the Canis Minor, which is the little dog. So yeah, it's a double star system that is exactly, well not exactly, roughly 8.6 light years away. So as you can see, now that we're talking about stars and other astronomical objects, we're going to start talking in terms of light years. Light years are massive amounts of time, millions of miles, millions and billions of miles. So yeah, 8.6 light years away, the double star system made up of Sirius A and Sirius B. Both of them orbit each other. So it's kind of like they're spinning around, orbiting each other. So yeah, Sirius A is the bigger and brighter star, and Sirius B, which is called the pup, like a puppy, is a smaller and dimmer star called a white dwarf. Like, remember last episode how a lot of these terms were intertwined with each other? It's going to be the same for this one. This is actually part of a Greek myth. It's the Greek myth of Sirius, which is believed to be a 2-headed dog. It's believed to be the hot day, the beginning of hot days, the beginning of the sweltering heat in ancient Greece, which, dog days, that is where that term derives from. It derives from Sirius, the dog days, the hot and humid and horribly hot, sweaty days. When people saw this star, we were just like, oh no, the big hot days are going to start coming, and maybe yeah. Fun fact, I actually kind of mentioned it. Sirius is a 2-headed dog, so that is the myth of Sirius. As you can see there, it's a 2-headed dog. Yeah, so that's what the Greeks believe, that this was the beginning of their hot weather back in ancient Greece. This is an interesting one to pronounce. Beetlejuice, like the musical? Is it a musical? Yeah, like there's a musical called Beetlejuice about like a guy who's green. I don't know. I've never seen it. It's the second brightest star in the night sky and is located in the Orion constellation. Orion is probably the most famous of all constellations. Orion the hunter with his shield and sword. Pretty interesting. A red supergiant. So it's one of the biggest in the universe. Remember we learned last time that these supergiants are massive. They're ginormous objects. The biggest star that can emerge from a starburst nebula. It's a red supergiant, and like I said, it's one of the biggest known in the super system, and it is very, 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 very hot. Average temperature is 6,500 degrees, so it is boiling hot. It is scalding. It is absolutely infernally hot. It'll burn you in an instant. Yeah. So, and because of its very hot temperature, it's kind of a bit of a paradox with this next one. Because of its super hot and red hot temperatures, literally red hot, we can see that it's near the end of its life. But Betelgeuse is a relatively very young star with only a life of 10 million years in astronomical terms. That is very short, very young. So Betelgeuse might not live that long of a life, considering a lot of these stars. Remember, like we learned last time, super heavies don't live very long lives because they consume so much hydrogen, so many elements around them. They take a lot to continue their nuclear reaction. So yeah. So what happens with Betelgeuse and stars like Betelgeuse and other supergiants, when these big supergiants start running out of hydrogen, when they start running out of hydrogen to you, which is kind of like the fuel for their nuclear reactions, sun-like stars like that we have like our sun, they usually die. And then we'll talk about how they die in a bit. But yeah, sun-like stars like our sun and was it Alpha Centauri? I believe so. Yeah, Alpha Centauri A and B. When those sun-like stars start losing their hydrogen, they die. But supergiants can start using their supply of helium. So yeah, that hydrogen and helium, they still have an extra reservoir that compared to sun-like stars that don't have enough. But yeah, fun fact, like I said, Betelgeuse is near the end of its life. So the eventual supernova, which we'll talk about, what happens at the end, the eventual supernova, the explosion of when it dies, will be brighter than the moon in daylight. It is going to be huge. You can even see it at night. It might be as bright as a full moon at night. That is how bright the supernova of Betelgeuse will be. So when it explodes, maybe in the next 100 maybe years, tens of years, maybe billions of years, keep an eye, because it's going to be a pretty interesting astronomical event. So yeah, here's a good feline friend, but a good feline friend that would take you millions and millions of years to get to. Cat's Eye Nebula. Not the cat eyes nebula, the cat's eye, like your eye. A Cat's Eye Nebula. Well, not a Cat's Eye Nebula, the Cat's Eye Nebula. It's a place in the universe that is a planetary nebula that is located in the Draco constellation, or Draco I think, which is the dragon. Here's Draco. As you can see, it's in the shape of a dragon. It has a dying star at its center, and it is 3,300 light years away, so you are not getting there anytime soon. It has a dying star at its center, and the shape of it, considering how the Cat's Eye Nebula looks, this is the Cat's Eye Nebula. That is what it looks like, and the shape of it could possibly signify that they have a double star system, kind of like what we saw with Alpha Centauri or Sirius. Both of them have double stars that are orbiting each other. So, how these Cat's Eye Nebulae forms, or planetary nebulas, that's what they're called. Fun fact about the Cat's Eye Nebula, remember how I said that radiation circling all those circling gas clouds? They are not slow at all. Those clouds are massively fast. 62,000 miles an hour winds are in the nebula, and they're concentric, which means they have the same center. So, what's an example of concentric? Our magnetic field. So you know how our Earth, let's say our Earth is right here. Our magnetic fields go like that. So the winds around the Cat's Eye Nebula, because it's all swirling gas, they circle around the nebula and they have the same center, which means concentric. So it's not that friendly of a place, even though it has a pretty nice name. Like I said in the last term, these next 5 terms, white dwarf, supernova, neutron star, black hole, and supernova remnant, are all interlocked with each other. Let's start with our first one. We mentioned this in the last one with the Cat's Eye Nebula, the white dwarf. We've talked about red dwarfs, brown dwarfs, yellow dwarfs like our sun. White dwarf time. It's a star that has the same mass as the sun, but has no gas, no fuel, it's dying, and it has no fuel for those nuclear reactions, those essential nuclear reactions that all stars need. So, that means, with no nuclear reactions, it's simply just a cold ball in space. So, that makes it one of the most dense things in the universe. It is super dense. I'll tell you how dense it is in our fun fact. It's scalding hot at first, so like we saw in the Cat's Eye Nebula, that dying star in the middle is dying out. So it's scalding hot at first, but then it fades to just a cold, dead, lumpless form. It's a star, but just cold and fades out, and yeah, that's how these white dwarfs usually end their lives. This is a white dwarf star. As you can see, it's all cold, dim, it's fading out, and yeah, it's not going to have a very long life for long as it fades into nothingness. This is usually, like I said, the remnants of a giant star. So, like I said, one time, like we said, in the Cat's Eye Nebula, there was a red supergiant that creates all those glowing colors, and that red supergiant is fading into a white dwarf. So once those red supergiants or supergiants use all of their fuel, they fade into white dwarfs. They start losing all their fuel, their energy, and they just get dimmer and dimmer and cold. They get dimmer. It gets colder and colder and colder, and that means it doesn't even have enough energy to fall under its own gravity and make a supernova, so it collapses on itself, so it just gets like squished down and starts breaking apart, and it becomes denser and denser and denser and denser and denser, because all that matter from the star is getting compacted. It's getting super compacted, it denses and crumples into a ball. That is what makes white dwarfs the most dense thing in the universe. Not the densest, but one of the most dense things in the universe. Fun fact about white dwarfs, a single teaspoon of white dwarf star material. So if you go to a white dwarf, which I don't think you can right now, but if you go to a white dwarf and you take a teaspoon out of it, that teaspoon can weigh as much as a 4x4 car. So your average car, your average minivan car, 1 teaspoon of a white dwarf star is about the weight of that. So imagine trying to pick that up with a spoon on Earth. It is super dense and super heavy. It is absolutely dense, but it's all dead. It's all dead matter from this star that makes it so dense and as it collapses on itself. Alright, so now that we've talked about white dwarfs, let me move to this side. This is a term that we've mentioned already a good amount lately. Supernova. This is a term we've been building up to. This is the stellar explosion. This is the thing that our episode is named out of. The stellar explosion. A supernova, and it happens when a supergiant dies it's so powerful that it can create star formations and nearby starburst nebulae. So it is so powerful, essentially, a supergiant just literally explodes. It just destroys itself. It implodes and it sends all the matter everywhere for light years, and it happens like that. It's super quick, and it just sends all the matter and particles and all its light everywhere. It's a giant, astronomically sized space explosion. Yeah. The leftover core that is left, so not all of the star gets destroyed, but the leftover core from a supernova can create either a neutron star or a black hole, which we will also talk about. So get excited for that. It happens when a giant star runs out of fuel for its nuclear reactions, and these supernovas can be almost 500 times brighter than the sun. So these are ginormously bright. Like I said with Betelgeuse, when it eventually enters its supernova phase, it can be as bright as the moon in nighttime, a full moon in nighttime. So I'm telling you, these supernovas are massively big. Get excited for when Betelgeuse explodes, if it explodes in our lifetime. So yeah, like I said, this is when stars run out of their fuel for nuclear reactions, and this happens, so let's get our physics in. So you have your force of gravity of these stars. It happens, supernovas, when the force of gravity caused by the star's mass overpowers all of the repelling interatomic forces. If you go back to, I forget what episode it is, but if you go back to season 2, card up here, if you go back to season 2, and I believe it's episode 4? Yes, it is episode 4, season 2, episode 4, when we talk about strong force, weak force, nuclear forces, or strong internuclear forces that hold our atoms together. So it's when the star's mass overpowers all that strong nuclear forces holding all the atoms together. It causes to collapse on its own gravity and just explode, expelling all of its matter everywhere. Fun fact, you know how I said it happens like that? The core's collapsing speed can get up to 43,500 miles per second. It is rapidly quick. These explosions are hugely fast. So yeah, the core just collapses on itself, and once the star's mass overpowers the intermolecular forces, it blows up, and it's never seen again. So, neutron stars. Like I said, these are the remnants of, it depends on the size of the star, but it's the remnants of a supernova. This is the leftover core after a supernova that has a solid crust of iron that makes a very small star and weighs more than the sun. So it's pretty heavy, these neutron stars, because it's all the leftover core. So pretty heavy stars. They are technically stars, but that doesn't mean there's a star inside a star. No, these are formed after the leftover core and all the matter just gets exploded out by a supernova. These have about usually a diameter of 6 to 12 miles, so it's pretty small. Only stars that weigh between 1.4 and 3 suns wide, so our star would create usually a nebula or a supernova, which would incinerate us all once it explodes. So it weighs between 1.4 to 3 suns, and so stars that weigh between 1.4 and 3 suns create neutron stars because of its unique characteristics of its very heavy density, and because it's very small. To escape its gravity, you have to reach half the speed of light. The speed of light is 300 million meters per second, so it's incredibly fast. I don't know what that is in miles per hour, but you have to have a very, 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 very fast speed if you're going near a neutron star, because otherwise you are going to get pulled into its gravity because it's so dense. It's the core of a leftover star, so you can imagine these are pretty interesting things. This is a neutron star, as you can see, pretty small, but at the same time still kind of has some of those star properties that you would usually see in your other stars. Very kind of bright, but not the brightest star out there, not the most spectacular looking star like a supergiant. Along with having a very strong gravity, it has a very fast spin. It spins one rotation around a second. So very, very, very fast compared to Jupiter that has an average day of 10 hours, which is also very fast for a planet. But yeah, neutron stars, very fast spinners, and is made of the neutrons. Why it's called a neutron star? It's made of the neutrons that form when electrons and protons, in a supergiant, join together. So as you know, are nuclear reactions that are occurring in the core of our stars. Protons and then electrons join together, and the leftover neutrons, because those protons and electrons get exploded out from the supernova, the leftover neutrons is the thing that makes our neutron stars. Some neutron stars can make beeping sounds, like literally beeping sounds, can literally pulse like this and be like beep, 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 and they can be detected on computers, and the beeping stars that can be detected on a computer and that pulse out like this, those are called pulsars. That is where that term comes from, and that pulsar is coming from a neutron star. Fun fact, there are over 2,000 neutron stars in the Milky Way, so there's about averagely, well actually not that averagely because there's trillions of stars in our Milky Way, so it's not that big of a thing, but there's over 2,000 stars, so there's about over 2,000 stars that are 1.4 to 3 suns big. So yeah, neutron stars, not that much of a rarity, but also, they're a bit of a rarity, but not that rare to find as well in our Milky Way. Ooh boy, oh boy, what a term. I remember when we were finishing up season 4, and I announced that we were doing astronomy, this was going to be one of the highlight terms of the season. Black holes, the endless mystery of space. No one knows what really they are. They're just things in space, but what we do know is that it's a mysterious hole in the fabric of space that only forms from, remember, from our supernovas. They can either have two consequences. They can form a neutron star or a black hole. So, when these stars explode, they can either make a black hole, which can only be made by stars 3 times heavier than the sun. So our sun needs to be 3 times heavier to be able to form a black hole. So, don't worry, the sun will not form a black hole when it eventually explodes, but that doesn't mean it won't be painful for us on Earth. Because they give off no radiation whatsoever, no light radiation, they can stay hidden because they're literally black in the fabric of space, and they can warp space-time, which is something we'll talk about because space-time is a weird concept. We'll say that for the end of the season. So yeah, they can stay hidden, they warp space-time, they absorb all types of radiation, they can swallow whole stars, they can swallow up, not galaxies are a bit too big, but they can swallow whole stars, they can eat light, not even light can escape its grasp, its pull. Its gravity is astronomically huge and sucks up anything in its path because of the stars, because of the massive amount of these stars, the mass of these stars. Black holes can suck up anything that goes in their path, even light. We have no idea where they go. They go to some endless point. They shrink down like a funnel. They get thinner and thinner and thinner and thinner and thinner and thinner until they shrink into a point, an infinitely small point, which is called spaghettification, or being spaghettified. As you know, spaghetti is a noodle, it's a very long noodle, so essentially if you were to fall inside a black hole, you would get stretched out even thinner and thinner and thinner until you are as thin as an infinitely small point, as you're broken down into your smallest subatomic particles until it is exactly the thickness of an infinitely small point. Not a very favorable death. You don't want to be sucked into a black hole because I don't know about you, but I don't want to be broken apart into subatomic particles and thinned down to the thinness of an infinitely small point. So yeah, doesn't sound fun. The temperature of these black holes, fun fact, is about 80 million degrees Fahrenheit. So that doesn't mean because they're very black and they don't let off any radiation doesn't mean they're cold. No, they are very hot. Remember, they are the leftovers of these supernovas. So they are boiling hot. Yeah. Alright. One final term to go. I'll go on this side. Yeah. One final term to go here in episode 5 of season 5. Yeah. Supernova remnant, or supernova remnants, however you like your words, plural or singular, is the remains of a supernova explosion that is essentially, like, you have your core, all that stuff that gets exploded out, that's this. It's the formal term for it. Supernova remnant, all that matter, all that dust, gas, are the major sources of cosmic rays in the Milky Way. So we have our Milky Way. A lot of the cosmic rays and radiation that comes from the supernova remnants. All that matter, that is really the explosion part. So if we take a picture here of a supernova, all that explosion part, those are supernova remnants. There are particles of dust, gas, matter, elements, metals that are exploded by this at searing hot temperatures that are emitted by these supernova remnants. As the star explodes, they can travel up to speeds of 62 million miles per hour during the explosion, during the supernova phase, as they explode out 62 million miles, 6.2 million miles per hour. That is lightning fast, even faster than lightning, like that quick. It's in an instant a supernova becomes a supernova. Yeah, it's amazingly fast and super cool to see. The superheated gas, like I said, the super boiling, scaldingly hot gas that's millions of degrees from these supernovas, can emit X-rays, cosmic rays, gamma rays, ultraviolet, every single type of deadly radiation you could think of comes from these supernova remnants. Cosmic rays, like I said, the major source of these cosmic rays in the Milky Way come from supernova remnants, which can make them look like thunderstorms as they cool down. They can make them look like thunderstorms with lightning and stuff like that, and make them look cool colors like you saw in like supernova. It looks nice, a lot of pretty colors, a lot of pinks and greens and blues. All that exciting of those molecules, like I talked about when we talked about, it was the Cat's Eye Nebula. All the exciting of molecules creates those cool colors of supernova remnants. Like I said, they're exploded out. They can consist of carbon, oxygen, sodium, magnesium, sulfur, and iron. All of those are life-sustaining elements. So they could possibly bring life to some planets, so who knows? Maybe supernova remnants are the key to discovering life. Final fun fact, the average weight of supernova remnant material, so if you like take a bucket of supernova, come on. Let's say you have a star, it explodes, it can turn into a supernova. All that supernova remnant material, if you were to gather that all up into a bucket, it would weigh about 1 times 10 to the 28 tons. So 1 followed by 28 zeros, which is about 10 non-million. Alright, that's the end. Let's go over announcements as we end this episode. What an interesting episode. Now we're done talking about stars. We've talked about the birth of stars and all the stuff that happens after they die. I've honestly got to say, all the stuff that happens after they die is pretty interesting. I think it's more exciting than the birth of stars. But yeah, that's 2 episodes of Stars back to back that you're done. We are done talking about stars, and we are done with Season 5, Episode 5. What an episode this was, or 2 episodes this was. I hope you enjoyed it. Announcements times. One thing I've decided over the past couple years, that the credits that we have, they're kind of outdated, as you can see. They're kind of outdated. That's a picture of me from 2019, so it's 2023. It's been outdated. Next year we will have new credits, so get excited for that. Next video, that surprise game I told you about, that Pac-Man game, that antique Pac-Man game, we are playing it next time out. Like I said, this past week was Thanksgiving, so I hope you had an amazing Thanksgiving if you are watching this in the US, or if you're from the US, happy Thanksgiving, happy late Thanksgiving. But next time we are playing Pac-Man coming on December 10th, so get excited for that. New Pac-Man game, December 10th. And after that, we have another Prietology, and then the Christmas special, which I've decided what we're doing this year. It's going to be pretty special. Get excited for that. So enjoy that. Coming on December 10th. So that'll be the next video. But the next episode topic, I don't know what the next episode is, but it's the 2 weeks after the Pac-Man video. Next episode topic will be about, we're getting even bigger than stars, galaxies. We are going to start talking about galaxies. We have 2 episodes on galaxies. All galaxies. We're going to start talking about galaxies. Yeah, get excited. We've got some interesting stuff here in Season 5. But yeah, thanks for watching. I will see you in 2 weeks for our new gaming video in Pac-Man. See ya. And remote. Happy holidays, everyone, and welcome back to Dprieto TV, and welcome to the last Prietology episode of the year. This is the 7th time we've done a Prietology lesson this year, with us doing the finale of Season 5 back in January, and now Season 5, Episode 6 today. We have 2 more episodes left in this season. Episode 6, the local group of galaxies. We finished talking about our solar system, stars, and now we move to the biggest things, and one of the biggest things in the universe, galaxies. Specifically, the local group of galaxies, a cluster of galaxies, which we live in. And we have a ton of other neighbors that we'll talk about today. So yeah, let us get back, and yeah, like I said, happy holidays. Christmas time, as you can see, my place is a bit decorated. As you can see, there's a stocking here. Hopefully there's something in there by Christmas Eve. So yeah, let us begin. I have some announcements at the end, considering we have the Christmas special coming soon. Get excited for that. And yeah, I'll stop talking now, so yeah, let's just go over key terms. Alright, so as we begin to wrap up Prietology for 2023, and as we're now hitting Season 5, Episode 6, let's go over our key terms. We only got 6 today, 2 less than we've had in the past episodes, in the past 2 episodes. Yeah, Milky Way, supermassive black hole, pretty interesting, Magellanic Clouds, Andromeda Galaxy, Triangular Galaxy, and SETI. That's an interesting one we'll talk about at the end. So yeah, let's go on our first term. Alright, let's kick off this festive episode with the first term. Our home in this gigantically, infinitely big universe, the Milky Way. Our home in the vast expanse universe that we call home, and it's about 13.7 billion years old. So, pretty old compared to other galaxies. Some galaxies in the local group are pretty young. So yeah, we are a relatively old galaxy. We were created long, long ago, and we house about 500 billion... That's wrong. That's supposed to say star. Alright, where was I? We house about 500 billion stars each, sometimes with their own planets orbiting it. So yeah, there is a ton of chance for life to be in our galaxy. Is there? Who knows? But yeah, it has 4 arms. As you know, it's a spiral galaxy, which we'll get into a bit. If you see the picture of the Milky Way before, there's a picture of the Milky Way. As you can see, very cool. It has 4 arms. They are called Perseus, Cygnus, Centaurus, and Sagittarius. Some of them are named after our constellation. So like Perseus is a constellation, I forget what it is. I think it's the warrior or something. Cygnus is the swan, Centaurus is the centaur, and Sagittarius is the goat. I think it's a goat, Yeah, alright. So yeah, those are the 4 arms of the Milky Way. We are in the Orion arm, which is a section of the Sagittarius arm. So, coming back to spiral galaxies, there are 3 types of galaxies that astronomers classify. Spiral galaxies, like our galaxy, elliptical, and irregular. I'll save those last two for next episode because we're going to be talking about them much more next episode when we continue about galaxies. Fun fact. Our center, the center of the Milky Way, is full of red and yellow stars, which essentially kind of makes it look like a fried egg. So if you look at a picture of the Milky Way from like far, far away, or not far, far away, but from like, if you were to go to like a bird's eye view of the Milky Way, which is a bit too far for us, it's full of red and yellow stars, so the center makes it look like a fried egg. So just, it's kind of like very cloudy around a very yellow, red center, orangish almost. Fun fact, if you ever wonder why it's called the Milky Way, it's actually pretty interesting. Milk, as you know, it's a liquid, it's comes from cows. It's called the Milky Way because in telescopes long, long ago, it looks like a bit of spilled milk from Earth's sky. So if you literally spill the jug of milk, not that I'm saying that you should, but if you spill a jug of milk, it kind of looks kind of like I said, kind of like that fried egg shape. So yeah, that's why it's called the Milky Way. Alright, if you thought black holes were interesting and somewhat frightening and exciting enough, supermassive black holes should really, 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 really interest you. Supermassive black holes. If you thought black holes are big enough, they could get even bigger. It's an astronomically huge black hole at the center of our galaxy, our Milky Way galaxy, and it has the strongest amount of gravity in the universe. It is incredibly strong. If you are sucked into it, you are a goner. You are being spaghettified into an infinitesimally small point that fast. You are gone. You're spaghettified and shrunken down. So yeah, the reason why we're not able to be sucked in is that there's a lot of stars around it. There's a lot of stars guarding it, and essentially, like, those are the stars around it. Those are the ones getting sucked in. We're a bit too far out to feel its effect, but yeah. So, we're safe. We won't be sucked into a black hole at the center of our galaxy, even though there is one. It works like any other black hole. They're just called supermassive black holes because they're bigger, which means they have a much stronger gravity than your everyday black hole, which is formed from a star, a supernova. Remember that from last episode? Card up here. It works like any other black hole in the terms that it has no radiation, is able to escape it, so light, infrared, X-ray, gamma ray, radio, microwave, ultraviolet, nothing is able to escape it. It's just more powerful, like I said. They just have a stronger gravity, unlike our other black holes. In other younger galaxies, supermassive black holes also exist. So, in these younger galaxies, they make the galaxies look like they're flashing colors at their center. These younger, smaller galaxies, if they have supermassive black holes at the center, they literally tear the galaxy apart. They suck it in from the inside, they just rip it to shreds, and then, with these supermassive black holes, they can expel tons and tons of
antimatter, which is something we talked about a long time ago in season 2, when we talked also about strong force in the center of the atom. So yeah, antimatter, it can be made from these younger galaxies which get teared apart from these supermassive galaxies. So yeah, not very friendly, these black holes. Fun fact, our supermassive black hole, like I said, in the center of our Milky Way is only 26,000 light years away. So light would, if you were to travel from Earth to the center of our galaxy, our supermassive black hole, 26,000 years it will take. So trust me, we are safe from this supermassive black hole. Nothing will harm us. For now. It's a shame this astronomical object is usually forgotten, but yeah, don't worry, we're talking about it. Magellanic Clouds, or Magellanic Clouds. I say Magellanic Clouds. It's a pair of dwarf galaxies named Large Magellanic Cloud, or Large MC, LMC, and Small Magellanic Cloud, or SMC. And they are named after the Portuguese explorer Ferdinand Magellan. That is a huge name in like New World explanation. Magellan. These are named after him. The Magellanic Clouds, I think it's because he actually found them. Actually, on a voyage once. I think that's someone on the ship probably looked into the night sky and was like, oh, these things look cool. Named after him. LMC is in the constellation Dorado, which is the dolphin, which is kind of interesting. It's not related to that whatsoever. And SMC, the Small Magellanic, oh my goodness. The Small Magellanic Cloud is in Tucana. The Tucana constellation, which is the toucan. You can see that's more similar. This is the Magellanic Clouds, and you can see they're pretty similar. They're pretty similar shape. There are two sizes that you can see, but yeah, they're like wispy little clouds traveling in the universe. And speaking of traveling in the universe, they are right outside the Milky Way, so they're also in the local group. All these things are in the local group, except for our last term. But yeah, these are also in the local groups. They sit right above it. They have a great view of the galaxy. They sit right above with a bird's eye view. It's fantastic to see them up there if we ever get to the Magellanic Clouds, which I don't think we can. The thing about the Magellanic Clouds is that the Magellanic Clouds in general weigh more than 1 billion suns, so they are incredibly heavy. They are dwarf galaxies, so they're very small galaxies, and they can shine as brightly as 2 billion suns. So yeah, they are incredibly bright and incredibly heavy. They could possibly even have galaxies inside them, both of them, and they also, along with having galaxies inside the clouds, they might even be orbiting our Milky Way. So who knows? We still don't really know a lot about these Magellanic Clouds. We just know that they're there, but we don't know really what they're there for. Do they just orbit around the Milky Way, or is it just a random pattern that just float around the universe? Do they have galaxies inside them? Could they have life inside them? Yeah, a lot of interesting questions in astronomy. Fun facts! The distance between the small and the large Magellanic Clouds, it's hard to say Magellanic, it's hard to, the distance between the two clouds, 75,000 light years. So they're not somewhere close. They're pretty macro far from each other. Pretty big distance between them. But yeah, pretty interesting terms. All right, we're halfway through the episode. Let's go into the second half. All right. Like I said, our galaxy is part of something called the local group, which is a big cluster of other galaxies that are around us. Here's one of our friendly little neighbors, but is it friendly? We'll have to see. The Andromeda Galaxy. You've probably heard of this before. It's probably the second most known galaxy in the local group and just in general, after our Milky Way. The Andromeda Galaxy, it's a neighboring galaxy and is the largest galaxy in the local group that is located in the Andromeda constellation, or Andromeda is the princess. It is also a spiral galaxy like our Milky Way, which means it has arms. This galaxy is also, in scientific terms, known as M31 or NGC 224. So if you wanted to call it that, that's fine. But most of the people just call it the Andromeda Galaxy because it's in the Andromeda constellation. Along with being in the local group, like I said, it is the biggest galaxy. It is twice as big as the Milky Way. So if you thought the Milky Way, if you thought your Milky Way home galaxy was big, this is even bigger, with over 1 trillion stars that are housed in the Andromeda Galaxy compared to the 500 billion that are in the Milky Way. So twice as much. It is huge, this Andromeda Galaxy. The thing that's interesting about the Andromeda Galaxy, just being another galaxy in the local group, is that it is literally, quite literally, on a collision course towards us. It is literally hurtling towards us, and it will hit the Milky Way in 5 billion years. So if you live to 5 billion years old, you'll see it. But trust us, for our generation, for probably 3 generations above, we'll be fine. We won't see our galaxy smothered and crash into another galaxy We'll talk about colliding galaxies next episode. Fun fact, the most distant object that we can see with the naked eye is the Andromeda Galaxy. That the most distant object besides like a planet or something like that, the most distant thing that we can see is the Andromeda Galaxy. It is incredibly far, but still, it's on a collision course towards us. But yeah, just another friendly neighbor in our local group neighborhood. Alright, we have 2 more terms. So we've talked about 2 main galaxies thus far. We talked about our home, the Milky Way, the Andromeda Galaxy. Let's talk about the 3rd main galaxy, the last of the 3 main galaxies in the local group, the Triangulum Galaxy. It's probably not that known as the other 2, but yeah. It's a spiral galaxy, and I said the 3rd of the 3 main galaxies in the local group, and it is located in the constellation Triangulum, which is, you guessed it, the triangle. It's the Triangulum Galaxy, located in the Triangle constellation. The spiral galaxy like our other 2 ones, so we got some big spiral galaxies. It's a young galaxy, but this is where the catch is. It hosts 95% of all matter in the local group. It's very small. Well, it's not really small, but it's a really young galaxy, but it has 95% of all matter in the local group. So it is very dense with all that. The other 2 just have a little bit more. So if you think about it, Andromeda Galaxy has about a trillion stars. Think about how much this has. It is expanse galaxy. It's really interesting, even though it's not one of our main known ones. The thing about the Triangulum Galaxy as well is that it's literally facing the Milky Way, so we can see it pretty easily with telescopes. It is a beautiful thing. This is the Triangulum Galaxy. It looks pretty cool. Yeah, it's kind of similar to our other galaxies. Like, remember that spiral galaxy shape in our local group? A lot of our local group galaxies, pretty spiral shape. It is one also. The other interesting thing about the Triangulum Galaxy, it's one of the largest star formation areas. It has one of the largest star formation areas in its arms. One of its arms, I forget what it's called. A lot of star formation. So remember our star birth nebulas from a while ago? Though a lot of those are located in its arms. So a lot of the stars that we have, sometimes they come from the Triangulum Galaxy. So you can thank the Triangulum Galaxy for making a lot of our stars. You can thank the Triangulum Galaxy for having 95% of all matter. You can also thank the Triangulum Galaxy for having a very cool constellation location. Triangle. The Triangle. It is the Triangle Galaxy. Too bad it's not shaped like a triangle. Fun fact about the Triangulum Galaxy, if we want to go to it, it would take us a long time because it is 2.9 million light years away from the Milky Way. So, unfortunately, we're not able to get to this beautiful galaxy anytime soon. So yeah, we got 1 more term to go, and it's pretty interesting. Alright everyone, here we go. The last term of Season 5, Episode 6. Our final term. Today's episode about our introduction to galaxies. SETI. It's not a galaxy, it's not a thing, it's a machine. It's not an astronomical object, it's an acronym actually. It stands for the Search for Extraterrestrial Intelligence. My intelligence kind of got fuzzy there, but yeah. The Search for Extraterrestrial Intelligence, and it literally does what it stands for. It searches for extraterrestrial intelligence. It's a big satellite, a big observatory machine, and it's essentially, it detects, it's there detecting signals possibly from aliens or alien life somewhere in the universe. If they were really alone, it's essentially, it looks for alien life and sees if we're really alone. Are we really alone in this vast expanse universe? Like I said, there are a ton of stars in our Milky Way, in our Magellanic Clouds, Andromeda Galaxy, Triangulum Galaxies. Yeah, are we really alone? Who knows? It literally sends out text messages or like signals or like literally messages with text and uses the most powerful radio telescopes in the universe, and not in the universe but in our world, and essentially just waits for a response. It's literally just beep, beep, beep. It just sends responses every single day and sees if anyone's home, see if anyone's out there in the universe. To hers, it's mostly been a bit of a failure almost. It's mostly just heard a lot of static from space, so it just really gets nothing back really. But yeah, is there the possibility of life? Who knows? We are in a big Milky Way. We're in a lot of stars surrounding us. 500 billion stars. The Andromeda has a trillion, so you gotta think there has to be some chance of life. Who knows? Fun fact, we actually have gotten a signal from SETI. SETI has actually gotten a signal before, back in 1977. It has gotten a message back, literally a text message back. Do you want to know what it said? Wow. That's literally what it said. Wow! Exclamation mark. That's literally what it said back in 1977. Is that a sign of life? Who knows? Are the aliens saying, wow, these people finally communicated with us? Who knows? We'll have to see in the future. So yeah, season 6, no, my goodness, why do I keep saying season 6? Season 5, episode 6 is done. We're done talking about galaxies for the meantime, so yeah, let's move on to announcements. Whew, what an episode. We finished talking about our first part with galaxies. Season 5, episode 6 is wrapped up like a Christmas present. Speaking of Christmas present, let's go to announcements. Like I said in the beginning of the video, this was our last Prietology lesson of the year. We've got a great year of Prietology. We finished season 4 and episode 6. We've done season 5, episode 1, 2, 3, 4, 5, and 6. 7 episodes total of this year of Prietology. That is a record for Dprieto TV. What a year it has been for this. I cannot wait to conclude Prietology with season 5, episode 7 and 8. The grand finale Prietology coming next year. Stay tuned for that. But more importantly, next video is the 2023 Dprieto Christmas special. Tune in. We're doing something brand new. We're not doing the challenges like we did before. Unfortunately, no Bean Boozled this year. But we're doing something new. You'll have to tune in. Write this down. This is the premiere date, December 24th at 2 p.m. Eastern. December 24th at 2 p.m. EST is the premiere of the 2023 Dprieto Christmas special. I've been posting, as you can see, Dprieto's Christmas countdown, and I'll be posting shorts next week on the week of Christmas, the week before Christmas. So yeah, get excited for that. It is Christmas time. We cannot wait. It is being, I know what we're doing. Filming, I'm going to start filming soon, probably the coming week, so yeah, get excited for it. December 24th at 2 p.m. Eastern. Speaking of Prietology, our next episode will be coming in, it'll be coming in 2024, but before that, I'll be taking a bit of a break. I've been working a lot on Dprieto TV, so the next video after the Christmas special will probably be coming mid to late January. I want to take a bit of a break for myself. And after that, we'll start back with Prietology. We'll start back with gaming, and yeah, we'll conclude Prietology. But yeah, the next episode topic for Prietology, I don't know when that's going to be, but the next episode topic will be Galaxies Part 2. But this time, we're going outside our local group, our home, and we're going into deep space galaxies. So, elliptical galaxies, irregular galaxies, the Virgo supercluster, redshift, colliding galaxies. What happens when galaxies ram into each other? What happens when that happens? And what's another one? Yeah, I forget the rest of the ones, but yeah, we got some interesting terms for the next episode of Prietology. But yeah, as you can see, I wore my Santa hat this time. But yeah, thanks for watching, everyone. I will see you next week on December 24th, Christmas Eve, for the Dprieto Christmas special. Tune in, you're gonna love it. I'll be putting a bunch of stuff out for that. So yeah, thanks for watching that, and yeah, I'll see you for this Christmas special and remote. Well, hello everyone, welcome back to Dprieto TV, and welcome back to Prietology. It's the first Prietology episode of 2024, and it's the penultimate episode of season 5. Wow, what a season it has been already. The penultimate episode. This is the longest ever season. The first time that we're doing episode 7, so season 5, episode 7 of Prietology. This time we're talking about deep space stuff. Millions and millions and millions of light years away. It would take light millions of years to get there. So very far away, and talking about deep space galaxies. We're continuing our tour of the galaxies. We'll continue to talk about briefly the local group. We'll talk about some things in the local group. And yeah, we're just going to continue to talk about galaxies. A big announcement at the end of the video. There's a big announcement at the end of the video regarding the future of Travel Tidbits and a possible future Travel Tidbits series coming in the spring. So yeah, maybe Travel Tidbits will come back. And next episode is the final episode of season 5, the grand finale of Prietology. It's the final episode ever, the series finale. So get excited for that. I'll stop talking. Let's start our Deep Space Divas tour, and yeah, let's get started and go over key terms. Alright, we got a short episode today here on the penultimate episode of the season. We only got 6 terms. A lot of them, like I said, center around galaxies. We talked about the local group, but we forgot to talk about the group that the local group is in. So, we have the Virgo supercluster, elliptical galaxies, active galaxies, colliding galaxies, that's going to be fun, Hubble Space Telescope, which is a probe, and a cool concept called redshift.
So, yeah, let's get started. Alright, let's kick off the penultimate episode of Season 5 with... We already talked about a group called the Local Group, which is what we live in, but we forgot to talk about that it's a group inside a group, and that group is called the Virgo Supercluster. It's a giant group of galaxies. It's the home of major deep space galaxies that contains thousands of galaxies. It contains millions of galaxies. That's a ton inside this Virgo Supercluster. You can assume just by the name it's huge. It's a huge supercluster. The local group is located on the outskirts of the Virgo cluster, so we're pretty far out from the center. It's about the biggest galaxy. It's the largest group of galaxies for about 50 million light years. Sometimes galaxies, how these clusters like the Virgo supercluster form, galaxies gather in groups and they're called clusters, and then those clusters gather in bigger groups and they make superclusters. So clusters, like the local group, is a cluster of galaxies, and then the clusters gather in groups and make superclusters, and the Virgo cluster is a cluster of galaxies, a group of galaxies, and the Virgo cluster is right smack dab in the middle of the Virgo supercluster. So that is why the Virgo supercluster, or the Virgo cluster is the difference, remember, between supercluster and cluster. So the Virgo cluster is made up of a lot of old, beaten up galaxies with 150 large-ish galaxies, like the Milky Way is pretty big. Or it's not in the Virgo cluster though, it's in the local group. But it's made up of a lot of beaten up old galaxies with over 2,000 dwarf galaxies. So it's pretty full compared to the local group. The local group, I believe, is smaller than the Virgo cluster, I believe. But yeah, fun fact about the good old Virgo supercluster, actually inside of the Virgo supercluster we have the Virgo cluster and the local group. They're running into each other. So currently, right now, the local group, so where we are in the universe, the local group, our group of galaxies that we're in, the Milky Way, is currently colliding with the Virgo cluster, another group of galaxies. They're mushing together. And yeah, hopefully, I don't think we're having any catastrophic results. We're colliding with them at about a rate of 155 miles per hour, which in astronomical terms is incredibly slow. So don't expect anything terrible to happen. For now. If you've heard of a shape called an ellipse before, then this will pretty much sound kind of familiar to you. So, ellipses can be found in space in the form of another type of galaxy. The second type of galaxy we'll talk about, elliptical galaxy. This is a picture of an elliptical galaxy. As you can see, they're very elliptical, very oval shaped. Why shaped like that? Let's talk. It's a huge elliptical squished ball of old stars. But the most important thing that makes it distinct is that it doesn't have the gases required to make stars. So it doesn't have your hydrogen, helium. Remember when we talked about stars in episodes 4 and 5? We need those gases, those elements, those crucial gases in those starburst nebulas to create our stars, like hydrogen, helium. 10 to 15% of galaxies in the local group are elliptical. So in our home, it's a pretty small minority, so about 15 to 10% of galaxies are elliptical. Its older stars orbit the center more at a very slow pace, but it's really kind of hard since it's an elliptical shape. So you can see it's a stretch out, squished ball of stars. So you can see the centers kind of over in an elliptical pattern with like foci at 2 points. Dwarf elliptical galaxies are some of the oldest galaxies, which means they're some of the first galaxies ever since the creation of the universe. So these galaxies, since they're the oldest, they're made of some of the oldest gas clouds that we can find in the universe. They're smaller, they're harder to find, but they outnumber all other galaxies in the universe, though. Giant elliptical galaxies, remember dwarf is a smaller, these giant elliptical galaxies are rarer, unlike these dwarf elliptical galaxies, but they sometimes have enough gravity to upset the mass of a supercluster. Remember we talked about the Virgo supercluster. If you think clusters are huge enough, Virgo supercluster is massive, but these have enough gravity, especially these giant elliptical galaxies, have enough gravity to even upset a supercluster. Fun fact about elliptical galaxies, the largest elliptical galaxy that we've been able to find is 1 million light years across. That is massive, and it'll take you 1 million years traveling at the speed of light to get from one edge to the other. So, the largest is 1 million, the smallest is 1/10 of the Milky Way. So, you can see that's a pretty big of a difference. I don't know how wide the Milky Way is. I think we learned about it in the last episode. I probably mentioned it, but yeah, I forgot. Active galaxies. It's kind of a conundrum because these are so cool at the same time, but somewhat horrifying at the other time. This is technically it's one of the other type of galaxies, not one of the main three ones, but active galaxies, they live up to their name pretty well. It's a galaxy with a supermassive black hole in the middle. Remember, we talked about supermassive black holes last time when we talked about the Milky Way. We have a supermassive black hole in the middle, or SMBH. So it's a galaxy with a supermassive black hole in the middle that actively, literally, is ripping it apart, is literally sucking in its inside. It's tearing it apart from the inside. This is a picture of an active galaxy. You see that stuff shooting out the bottom and the top? That is it. That's all the energy created by it. Literally a galaxy it's having itself torn apart by its own supermassive black hole in the middle. It's a horrifying death for these galaxies, to be torn apart by something so strong and powerful as a black hole, a supermassive black hole at that. So like I said, the massive energy created by these SMBHs unleash some of the biggest storms in the universe, some of the biggest solar storms. Like I said, let's put that picture back up. So much energy coming out of that, you can assume how much storms and energy and power comes out of such a terrible amount of energy like that. It's huge. So with this massive energy, it shoots out a massive energy like electromagnetic energy. So you got your rapid waves, your very, very fast high energy waves like X-rays, gamma rays, and other radio waves. You can say all the other waves on the electromagnetic spectrum. And as you saw in the picture, it can make a fountain formation out of the top of these galaxies, out of the bottom. So it's kind of like there's something in the middle. It's kind of like this pen or this marker, and then there's the galaxy around it. It's kind of like that, like a skewer. Fun fact about active galaxies, if that wasn't already enough, it was discovered by, let's see if I can say this right, Carl Keenan Seifert. Carl Keenan Seifert in 1943, I assume. He used one of these radio telescopes, and these can also make pulsars. Here's another type of galaxy. It's not one of our types, but it is super cool. I'll show you some images. Colliding galaxies. It literally is what it is. Two galaxies, the deformation that occurs when two galaxies literally ram into each other. So remember last time when we talked about the local group, we said that our Milky Way galaxy, where we live, and the Andromeda galaxy, another galaxy in the local group, are heading towards each other. Won't happen for another billion years, unfortunately. So yeah, it's two galaxies crashing into each other, and it usually occurs between two middle-aged galaxies because they are whizzing around more, they're bigger, so there are more formations are being able to see. Because say you have like a little galaxy, like a little dwarf galaxy, and then you have a giant galaxy like Andromeda, like what we talked about, a little dwarf elliptical galaxy and then a giant spiral galaxy like Andromeda. That little galaxy is getting eaten up and destroyed in a second. So the galaxies, the reason that these galaxies collide is not that they're just like, it's kind of like traffic. It's essentially just a giant traffic, a car crash in the middle of space. The reason that these galaxies collide is that they're drawn towards each other due to their massive gravities. The gravities of galaxies, people, are huge. The force of the collision, making them, the force of impact between two galaxies is massive as well, and it makes them spin into cartwheels. Essentially, it's like, and then they just like spin and then go like this and then just start deforming into each other, and they form essentially one spiral arm. This is a colliding galaxy. You can see each galaxy kind of has like its own spiral arms deforming into each other. This is a process that can take a long time because if you look up a video of a colliding galaxy, and you can tell it's over a long period of time that these galaxies collide. Because they have to travel a massive distance to be able to form each of them their one spiral arm. And yeah, it's pretty interesting. And usually what happens after the collision, stars can sometimes form. Stars can form from this collision. Remember our starburst nebulae from when we talked about stars and how they form. They're hydrogen helium. There's so much gas that makes up these starburst nebulas, and they're stars. So sometimes, if the conditions are right between two colliding galaxies ramming into each other, is that stars can form, and then the gases created, the other gases like left behind by the galaxy, just drift off into space and just become one with space. Fun fact! Average time, like I told you, it's a very slow process. The average time for galaxies to merge after one collision, so you have two colliding galaxies, for them to merge and, like I said, create those stars, and then the rest is driven off. So the average time for these galaxies to form after the collision is 1 billion years, billion with a B, as in B as in ball, 1 billion years for these galaxies, colliding galaxies, to merge together and create one single galaxy, just some random cluster of gas, stars, planets, and other stuff. Yeah, penultimate, what's it called? Penultimate topic. My goodness, I cannot speak. If you haven't heard of this space probe before, look it up. Before watching this, you should look it up because I'm essentially going to go over it fast because usually people heard of this. It is the world famous Hubble Space Telescope. Now replaced by the James Webb Telescope, but this one's still active. The Hubble Space Telescope, the world famous space telescope. It's not here on land. It's up in the atmosphere, taking amazing pictures of space. It has taken some of the most beautiful pictures, won awards for some of the most beautiful pictures of space you've ever taken. This was taken by Hubble. This one, it can see pictures of galaxies, nebulas, planets, stars, even colliding galaxies. Some of those pictures of colliding galaxies, that's from Hubble. So yeah, great thing, great Hubble Space Telescope. It's an amazing thing. And yeah, let's talk about it a bit more. It can see in almost every frequency. It can see in ultraviolet, infrared, radio, microwave, light, X-ray, gamma ray. So it can see in all those frequencies, which makes it able to pick up so many images. It can focus on a little microscopic, nanoscopic speck of light that is millions of light years away. Because think about it, that light from that star or that thing it's trying to capture has to travel millions of light years to get it where it takes millions of years for it to get there. And Hubble is able to center and focus on it where it is. Actually, what happens with Hubble, since it's able to photograph stuff so far away, essentially, it's been able to look back in time. Sort of, technically. It's that it's able to capture light from galaxies. Let's say you have a galaxy. It's been able to capture light from galaxies even 13 billion miles away. Not miles, light years away. We're talking astronomically. 13 billion miles away. And essentially, it can help astronomers look into the universe as it was long ago. Because think about it, 13 billion, the Earth, some people think that the universe was created 13 billion years ago, sorry. So, looking at that light essentially kind of gives us an image of what the universe looked like 13 billion years ago. Fun fact about Hubble, it takes 97 minutes to orbit Earth. I forget how long the ISS takes. I think it's 90 minutes for it to orbit Earth. So yeah, pretty speedy thing, orbiting the Earth, because it's got to go all the way around the Earth. It's pretty fast for a space telescope. Alright, the final term of Season 5, Episode 7, the Deep Space Divas. And what divas we have talked about today. The cluster, elliptical galaxies, active galaxies, Hubble space, colliding galaxies. This is where it kind of all wraps up. We're done talking about galaxies after this episode. We got the final episode next, the series finale. So yeah, let's talk about something interesting. You're going to want to pay attention to this because I'm going to throw a lot at you. So hopefully pay attention. Hopefully it gets through your brain. Redshift. I don't know if you've heard it before. It's kind of a weird astronomical concept. It exists. It's a concept. It's a thing. It hasn't technically been proved. Well, actually it has been proved, but it's not like the evidence is super clear. But it's a concept, redshift. It's a concept that proves that the universe is constantly getting bigger. The universe, have you ever heard that? The universe is expanding. People say it's true. The universe is constantly getting bigger as we speak. And it can make rapid galaxies, fast galaxies, farther galaxies look redder than they actually are. So, let me explain. You have your electromagnetic spectrum. Let's put an electromagnetic spectrum in my hand. This is your electromagnetic spectrum. You have red on my right side, no, on my left side, and you have the other ones like purple, ultraviolet on my right side. So, essentially, all the light coming from galaxies can shift in frequency because they're so far away, we're talking millions of light years. When it comes toward us, towards our visible eyes on Earth, it can shift in frequency. And remember, we talk about our electromagnetic spectrum, it's going to go from either this way or that way. So, and sometimes, because they're so far away, they lose energy. And if you lose energy on the electromagnetic spectrum, you go towards infrared. You go over infrared, and some of our more redder, darker colors, like red, is a darker color. And because some of the many deep space objects that we have are traveling away from Earth, light from them, like I said, is shifted towards a redder, lower frequency, making them look redder than they actually are. That is red shift. It's literally shifting towards a redder color, making it look actually redder than it is. So, yeah, that's redshift. Because it's faster, that means that galaxies that travel faster, which, like, I don't know a galaxy that travels faster, because all galaxies, except for elliptical galaxies, those are slow. Galaxies that travel faster tend to have more redshift because they're whizzing off in space. And so, because they travel faster, that means that the faster they go, the more redshift. That means that the farther a galaxy is, the more redshift. Take a break and let's talk about a fun fact about redshift. It was actually the Hubble Space Telescope, the aforementioned Hubble Space Telescope, that discovered redshift. So it wasn't our human eyes, it was the Hubble Space Telescope. I'm telling you, that thing can see in every spectrum imaginable. That thing was able to spot redshift, I forget when, but yeah. It was the one that figured out that everything, like I said, the universe is expanding, which means that everything is traveling away from us. So theoretically, these galaxies are going to get redder and redder and redder and redder because the light coming from them has to travel a greater distance, which means it's losing a more amount of energy. So yeah, the universe is expanding, people. Whew, my goodness, that took forever. Whew, but yeah, Season 5, Episode 7 is a wrap. Let's go over announcements, which we talk about the series finale and some upcoming things. I'm still a bit tired talking about redshift. My goodness, that was a lot. But yeah, that is the penultimate episode of Season 5 done. As you can see, I don't have my lava lamp this time, unfortunately. It's somewhere else. But yeah, good old Statue of Liberty that we had last season. But yeah, alright, announcements time. Travel Tidbits is coming back. Yay! I don't hear you cheering, but oh well. Travel Tidbits is coming back here in 2024. We are going to... This location has been determined, but we are most likely going to... Las Vegas. We are going back to Las Vegas. That's going to be interesting. We haven't been there since the fall 2019 vacation. It has been a long time since we have been able to go there. It'll most likely come late March, early April, so it's still a long time till it'll come, but possibly get exciting. Hopefully the plans don't change. We are still deciding some things where we want to do in Vegas, but yeah, it'll be late March, early April 2024, Las Vegas for Travel Tidbits. It'll be in a series like we did for the Mexico vacation last year. So yeah, get excited for that. But I'll be putting out a poll soon of a game that I could play soon now that Prietology is coming to a close. I want to try doing some new things. I'm graduating soon. I want to do like a college vlog thing, but that'll come during the summer. But yeah, I'm going to put out a poll soon, probably next weekend, about some games that I could do, considering that we're going back to gaming soon. But yeah, next episode is the final episode of Season 5 and the final episode of Prietology in general. It's the series finale. Do not miss it. It'll be a full-fledged finale. We'll celebrate the past 4 incredible years of Prietology and the 5 seasons that we've been able to do, and close out Prietology Season 5 and the series with a bang. So get excited for that. That will be coming. It will premiere, mark this in your calendars, April 21st, 2024. That will be the finale of Prietology, the series finale, and the Season 5, Episode 8. Get excited for that. We will be talking about the universe and space-time. The concept of space-time is a mind-boggling thing. We'll talk about dark matter, the Big Bang Theory, not the show, the actual Big Bang Theory. Space-time, dark matter, dark energy. What the heck is dark energy and dark matter? And the possibility of it leading us into the future. Stuff like gravity. Like, what the heck is really gravity, dark matter, and the possibility of like other dimensions existing. We're gonna wrap up Prietology with a bang, talking about our existence into the future. The next video of Dprieto TV will actually be Cuphead. We are going back to Inkwell Isle. That will come on March 4th. So get excited for that. Cuphead number, I think it's 10. Yeah, Cuphead number 10 coming on March 4th. Get excited for that. But besides that, yeah, that is an end. We hope to see you for the finale coming on April 21st. But yeah, Cuphead number 4 next time. Get excited for that. And yeah, thanks for watching, everyone. And yeah, see ya. And remote. Well, hello, everyone. Welcome back to Dprieto TV. And welcome to the grand finale of Prietology Season 5. And not just Season 5, but of Prietology itself. This is the final episode of the Prietology series. Wow, what a journey we have been on for these past 4 years, making now 5 seasons of Prietology. So yeah, welcome to the series finale and the season finale of season 5 of Prietology. We're on episode 8 today. Today we're talking about the universe. Today we're talking about like the Big Bang Theory, dark matter, what even is all that stuff, and astronomy for the future. What does the future of astronomy hold? Now, here in 2024, and maybe in 2104 or 2124 in 100 years time, but we'll have to see what it looks like. So, since it is the series finale, there's going to be a lot of stuff going on, not just today's episode, but we got other stuff. We got compilations, we got special things that we're doing. And yeah, there's a ton of special stuff to celebrate the series finale, Prietology. It has been such a journey. It's been such an amazing adventure. We have done so much Prietology in the past 4 years. I've enjoyed it a lot. I hope you guys have as well. So today we are celebrating all that as we finally conclude the series. This is the last episode of it, and do not miss it all. So I hope you enjoy it. So yeah, I see no reason to keep talking. Our lava lamp is at full speed. We got everything ready. So yeah, let's start off Prietology Season 5 Episode 8 as usual and go over the key terms. So, here we are everyone, the series finale of Prietology. We have started every single episode, now all 30 episodes including this one, with this, the review of our key terms. So, let's go over our key terms. We have only 5 terms today in today's finale, but we got a lot of other stuff. Pay attention to these final terms that we will do the final 5 terms in Prietology with the Big Bang, W map, dark matter, dark energy, and space-time. So yeah, let us get started. Alright, so as we start to look into the future, there we go, you can see me. We're not looking into the future. Let us start with all the way back at the beginning of the universe, the Big Bang. You have heard this many, many times. There's even a show about it which doesn't really mention the Big Bang Theory at all. It's a comedy, really. But yeah, the Big Bang Theory is how the universe was created, and supposedly, according to scientists, it occurred about 13.7 billion years ago. So we have been around for a good long while, and some of the galaxies that we have in today's galaxy, especially like some in the local group, have been around for that long. And we have had a lot of stuff happen in our universal history, a lot of things being created. Some things, like say like galaxies or stars, are older than others. The Big Bang created all matter, all forms of energy and order in the universe. So before the Big Bang, there was a lot of like entropy. We've talked about entropy before, I think in season 2 with physics. Go check that out if you want to. We talked about entropy there, and that's like the measure of disorder, the measure of chaos in the universe. With the Big Bang, all that was put in order, and uniformity was created, and things like planets were created, things that were uniform orders of matter were created with the Big Bang about 13.7 years ago. One thing that helps to explain the Big Bang, of course, it's a theory. It's not been proven yet because you can't literally go back in time and check. It's a theory that there was like a little cluster of energy, and then all of a sudden it just bang. It's all matter, all energy, everything that we have in the universe just went out, and then the universe was created. So that's essentially that in a nutshell. It helps explain things like redshift, which we talked about last time, which is a really interesting concept. How light bends as a planet reflects light and it heads towards us. It's sometimes a different color because it loses energy, and this goes more towards a red in the electromagnetic spectrum, which is why planets or stars aren't usually the color that we see them in. And it also helps explain that the universe is constantly expanding. The universe is expanding at a rate as we can't even imagine. It's always expanding, and so those planets are going to get dimmer and dimmer and dimmer as they get so far away. But don't worry, that will happen for a billion years. So yeah, that's what the Big Bang Theory helps explain. The actual bang of the Big Bang Theory occurred in a fraction of a second. So imagine all that energy and then just boom. Universe. Done. You have your universe created. It doubled in size with the Big Bang in under 1 trillionth of a second. 1 over 1 plus, give me a second, 15 zeros. 1 divided by 1 followed by 15 zeros. So that is that much of a time, probably even shorter than that. The universe just doubled in size after the Big Bang, so it's a pretty fast bang. Fun fact about the Big Bang, the initial temperature of the Big Bang, I don't know how we got this reading, but I'm guessing through like celestial bodies and a complex math and something like that. The actual Big Bang, the initial temperature of the actual explosion had a temperature of 1 times 10 to the 34th power degrees Celsius. So imagine that, 1 followed by 34 4 zeros. That is a massive amount of energy. The amount of energy that was expelled is probably boiling hot. It would just, yeah. It was a giant explosion. Alright, so how scientists really analyze things like the Big Bang or things that occurred a long time ago, you need something to analyze that, right? Say hello to WMAP or WMAP or WMAP, however you want to say. It stands for the, here, I'll type it right here. It stands for the Wilkinson Microwave Anisotropy Probe. That's what it stands for. The Wilkin Microwave Anisotropy Probe, which can measure the heat of the ancient universe. That is really its main goal. It measures the heat and the leftover energy recreated from the Big Bang from the ancient universe. It was launched in June 30th of 2001. So it has been in space for more than 20 years now. 23 years. Right, I can do math. 23 years it has been in space measuring the heat of the ancient universe. If you ever wonder where we get that number of 13.7 billion years ago, it comes from WMAP. I'm going to call it that. It comes from WMAP, and it comes from the Wilkinson Microwave how we get this measurements from the WMAP is that it measures something called the cosmic microwave background. The cosmic microwave background. It measures that. That is how it's able to date the universe and measure the oldest remnants of heat left from the Big Bang. So, like I said, the cosmic microwave background is essentially like a visible glow that can be seen not in the universe, but, well, in the universe. It's a visible glow that can be seen in the universe that are leftovers from the Big Bang. So, very, very, very old heat that all the matter that's being expelled, that was expelled from the Big Bang, the cosmic microwave background is that remnant of the Big Bang. So how the WMAP works is that it takes samples of irregularities it finds and then it compares it to the norm. So all the irregularities of heat that it finds in the ancient universe. So it's like, oh, this one seems a bit, this is at a different temperature than what this is supposed to be. And yeah, so it takes that irregularity and it stores it and it sends it back to Earth for more analysis. The equivalent of this essentially checks every single grain of sand in the Sahara Desert. The amount of work that this does is equivalent to checking every single grain of sand in the Sahara Desert. It would take millions of years. It would take you thousands of years. Fun fact, the cosmic microwave background, or sometimes called the CMB, it comes from a time 400,000 years after the Big Bang. So in astronomical terms, considering the universe is 13.7 billion years old, the WMAP is able to find heat that is from a long, long, long time ago. So, yeah, that ancient heat gives us keys to the early universe to see what it was like and how the life formed after the Big Bang. So, yeah, you can thank the WMAP for that. So, as this is the last season of Prietology and the last episode of Prietology, I thought that since it is the series finale and we conclude everything after 4 years, let's take some time to reflect, and here are the best moments from Season 1 and Season 2 of Prietology.
Hi everyone, welcome back to Dprieto TV. I know with this coronavirus pandemic, these are difficult times. So, since a lot of schools are out and not a lot of people are learning a lot of things, I was thinking that I could bring my knowledge of science, because I love science. It's a beautiful thing to study. So, I was thinking I could bring my knowledge of science to you guys and, well, teach you guys about science. So, basically what I'm going to do, this, as you saw in the title, this is Season 1, Episode 1. So basically today, each day I'm going to do lessons based on like different topics. So today you saw is the basics of chemistry. So that's what today's episode will be about. So I don't think there's any other aspects, so let's get started.
Atoms inside a solid are very slow, so you can see my model atom here. You can see it on the camera. Can you see it? Okay, so this is the experiment of the day. So each class, at the end of the day, I'm going to show you guys an experiment that you guys can do at home. Hi everyone, welcome back to Dprieto TV, and welcome to the new episode of Prietology. So the metals during metallic bonding, they're held together in a lattice of positive ions. An example of a lattice, if you don't know what a lattice is a badminton racket is a good example. As you can see here, this is like, a lattice is basically like this square checkerboard kind of pattern. Okay, so the next term. Who is this? Hi, I'm secretly tuning into your lesson because I hacked your network. Oh, okay. Well, why would you do that? That's just my only question.
I called you because I have a question from your lesson.
Okay, well, what's your question?
Okay, so the question is, how are acids and bases related?
Okay, well, actually, that's actually a really good question. Let me explain. See, oh boy, this is getting full really fast. Oh boy. Oh, mackerel.
Put more in.
Okay, no, it's overflowing.
Hi boss, does that mean we get to blow things up today? Absolutely not, not in here. What about like dissolving or setting things on fire or exploding or lasering or whatever there is in chemicals? No, just no. Okay, how did you even get inside my home? You're supposed to be at the lab. Well, yeah, how did I get inside? Meh, I'll just leave you. But sorry boss. No more chemistry lessons for season 1. Our next topic is physics. Hi everyone, welcome back to Dprieto TV and welcome back to Prietology. We are starting with season 2, and if you haven't watched Prietology, I recommend watching the entire first season, which was about chemistry, up here. On 3, 2, 1. Alright. Let me think. $20 million joules is in 100 grams of chocolate, so basically it has a lot of energy. Well, looks like we covered all our key terms for today, so let's get on to experiment of the day. Together, it'll create an explosion in the universe so big it releases a flash of raw energy across the universe. This is also, I think a photon is also on the standard model. Here's a picture of the standard model right here. I think it's on it. Oh well. Come on, screw. Screw. Come on, it's not working. The topic for season 3 of Prietology is biology. We're gonna get
It's interesting to see what early Prietology was back in season 1, season 2. I look so young. That was 2020, early 2021. Sheesh, that was a long time ago. Season 1, season 2 was chemistry and physics. I love those seasons. Those were fun. We did the experiment of the day. Unfortunately, we aren't able to do experiment of the day anymore because doing experiments in space is kind of hard for me because I don't have billions of dollars. Well, as we were wrong, let's talk about dark matter. Dark matter is a mysterious thing. We don't know whether it's a type of matter or it's like an ordinary, weirder version of matter. So it's still kind of unknown what really dark matter is. All we do know, or a good amount that we know, is that it makes up a lot of the universe. A lot of the universe that we have today is made up of dark matter. Whether it's ordinary matter or a very special version of matter or its own version, still yet to be seen. So one thing that scientists were able to do, a breakthrough in dark matter, is that we were able to map the universe's dark matter, the visible universe's dark matter, back in 1997. So we know where most of the dark matter in the universe is, and the thing about dark matter, it's hard to find. There's actually something interesting in the book that we have. This book, where we get a lot of notes from Prietology, how I'm able to make these, is that it's actually a really funny thing what they did. Is that they mentioned like scientists, astronomers, they put dark in front of something they don't understand in space. So like weird types of matter, dark matter. A weird type of energy, it's not understood, so let's put dark in front of it. It's kind of funny. So yeah, so dark matter is still not clearly understood. It's hard to detect since it doesn't interact with any type of EMF or electromagnetic radiation. So yeah, so it can't react with radio waves, microwaves, infrared, light, X-ray, gamma ray, anything, or ultraviolet. It can't react with any of that, and that's one of the reasons it's hard to detect. So the way we're able to detect it is with very, very special instruments that we have that cost billions of dollars, which I can't show you. So they can be seen pulling on regular matter with its gravity. From what people have seen, they think it's denser and has a greater gravitational pull than regular matter. So if we see matter like clumping towards something, then yeah, there we go. We might find dark matter. It can also be seen spinning galaxies faster. If we see a galaxy that's spinning faster than it usually is, it's probably the gravity from the dark matter pulling it and making it go a bit faster. Or another way to see is that it makes light warp around invisible things. It doesn't glow. The dark matter doesn't glow because remember, it can't absorb any electromagnetic frequencies. It makes the light bend because of its gravity, and that is part of the theory of relativity, which means that light is able to be bent, and yeah, it's kind of it. That one thing that dark matter does is it also keeps galaxies from breaking apart. People think Now, without dark matter, we wouldn't be here. We would be flung off somewhere in space, and yeah, dark matter is the glue that holds our galaxy together. Fun fact, earlier I mentioned that it makes up a lot of the universe. It makes up 23% of the visible universe that we know today. So that is very, very far. That is a lot of dark matter that makes up the universe. It might seem like a little bit, but without dark matter, our galaxy would fall apart. So, thank you, dark matter. Alright, this might seem familiar because we kind of talked about it-ish in the first one. We had dark matter, but let's talk about the penultimate term in all of Prietology, dark energy. This is more unexplained. We know more about dark matter than we do know about dark energy. It's an unexplained force that partners up with dark matter, and it envelops the universe, and it tries, this is weird, to pull it apart, essentially. That's really what dark energy is. We don't really know what it is. Besides that, it's trying to pull apart the universe, and as it remember how it's expanding, all the expansion is trying to pull it apart. That's the part about dark energy, and it envelops the universe. It's not really like a form of like energy, not like thermal energy or nuclear energy or chemical energy. It's more like a force, although work is force times distance, so I guess that's how they can classify it as an energy. So the thing about dark energy, it was very crucial in the first seconds after the Big Bang and somewhat responsible for its creation of the universe. Without dark energy, remember, like I said, it envelops the universe, we probably wouldn't be here today. This is the fabric, well, some part of the fabric, not exactly. This is some part of the fabric that makes up our universe. Without dark energy, we would not be here right now. So, super crucial after the Big Bang. The thing about dark matter is, the thing about dark energy, sorry, not get this mixed up. How, like I said, it's pulling the thing apart. It's because it has something very special called anti-gravity. Anti-gravity, we've heard in like sci-fi or like superhero movies, like anti-gravity. It's like, oh, I can like float off the air. No, this is anti-gravity in a scientific way that somewhat exists, somewhat is not explained yet. So, if you have the pull of gravity from like a star or some massive celestial object, and dark energy, since it has anti-gravity, works in the other direction. It repels gravity. So that is how it is able to pull the universe apart. It's pushing everything in, but at the same time it's pulling it apart that way. It always repels the force of gravity, making it anti-gravity, which means that it is pulling our universe apart, like I said. So astronomers were looking at supernova explosion and saw that the universe's expansion because of that was speeding up. If it's expanding like this, dark energy is trying to pull it apart, which means that with that supernova explosion, the expansion is speeding up because dark energy is trying to pull it apart. Fun fact about dark energy is dark energy particles, which we haven't discovered. Well, we haven't like discovered-ish yet. We haven't like seen them. It's kind of like dark matter is not visible to us, since it literally envelops the universe. Dark energy particles act against gravity's pull, like I said, to make something called anti-gravity. So gravity goes this way, then anti-gravity will go that way. It always repels the force of gravity, which means that it is pulling apart our universe, but trust me, we'll be fine. For now. Probably in the next billion years it might happen, who knows. So, we've already reviewed Prietology Season 1 and Season 2. Let's take a look at the best moments from Season 3 and Season 4, and then we're on to the final term.
Well, everyone, we're back. Welcome back to Dprieto TV, and yes, Prietology has returned. We are here to start Season 3, and as you can see by all the plants and stuff that surrounds me, let me move this over here, we're doing biology. Also, big announcement for this season that is going to change. There's not going to be an experiment of the day for this season. This episode, however, will not have one term, will not have two terms, but a record-breaking 19 terms. No, don't mess with them. Like, no, this is, I beg you, I actually restrict you from touching this animal. Please do not touch it. It's a real big organ, makes up 2% of your body weight. That's a lot. So basically, take your weight. Mine is, oh, hold on, I have a calculator near me. Hold on. The liver is 1 kilogram in my body. We're talking about these. These are flowers, if you didn't know them. Pretty cool things. The things that flamenco dancers hold in their mouth when they dance like this. Yeah. Adenine, guanine, thymine, mining? I don't know, I have to check that later. Alright, all the proteins are being made, everything's good. Sir, we have some new genetic code, you might want to check this out. Yes, alright, thanks genome.
Where is it? There's nothing on this paper. What are you talking about? Where's the code? How am I supposed to do transcription translation with this? I don't know, boss. That's what Protein gave me. If you want, I didn't do anything. You could ask Protein. I was just given it. I was just told to give it to you. Seriously? Fine. Protein, get over here right now. Yes, boss? I was just trying to transport these ribosomes so we can just go do more functions. What's the problem? Oh, problem? You want to know what the problem is? Look! Where is the code? It's empty. The base strips aren't even there. What are you expecting me to do? Not transcript and translate? The cell will die. What? What are you talking... Did Genome tell you this? Because if he did, he's a liar. I did nothing. I'm just telling him. He's the one who has to write the code down. I just transferred ribosomes, okay? Yeah, I just transferred ribosomes. But it's entirely his fault. Me? You're calling me Did any of you call? Well, everyone, welcome back. It is Prietology Season 4. Collisions between plates, because plates don't just go smoothly like F1. Like, remember how in Formula 1 when I played, there's collisions all the time. Beat him down the street. Let's beat him down the street. Come on. Push me off. No. Ah, there's 4 cars everywhere. Plates are exactly like that, except they're not cars. Before we move on to the next term, I want to do the demonstration to see how, like, the sun's heat, the sun's light affects like things like latitude, longitude. So yeah, let's dim the lights. Alright, that's my best interpretation of the US. Now let's make Florida. Florida would essentially go right there. The Pacific, the Atlantic, the Indian, the Arctic, and the usually forgotten one that no one remembers, the Southern Ocean. Right there. There we see a picture of a front chart, so like the weather in the coming area. The lines with the blue triangles, that indicates a cold front, and the line with the red like semicircles is the one that indicates warm front. Season 5 will be about... We're gonna do an extended drum roll. We're heading and we're reaching for the stars. We're going to talk about astronomy. Wow, wow, wow. Prietology has evolved so much since we began it in 2020. The reason I began it is that during COVID, I really had nothing to do and school was out, so I might as well have brought my scientific knowledge to you. But we have come so far over so many years. We've done 4 seasons. Now that we're about to conclude the 5th season, this is the final term of Prietology history. Enjoy this, everyone. This is the final term. This is the final term we'll ever do, and we are going to talk about one of the most crazy concepts really, that we've ever talked about on this. This is the thing that controls all of the universe, the thing that makes the entire universe and possibly beyond the universe. The space-time continuum is defined by something called space-time. Space-time is the very 4-dimensional fabric of space that makes up the universe. Yes, you heard me right. 4-dimensional. 4 dimensions. This is, have you ever heard someone talk about, like, ooh, the fabric of space, the fabric of the universe? They're talking about space-time. Space-time is a weird concept that was defined by someone. I'll get to that a bit later. So, how it works is that it can warp. It warps, so, like, if it's, say we have our space-time fabric right here, and if it warps down like this, gravity is going to be pulled like that. It's kind of like a fabric. That is why it's called the fabric of space. Because let's say you have, a good way to explain it is, let's say you have a stretched out fabric, and you put like a metal ball in the center, but then if you pull the fabric underneath, the ball is going to fall towards it. It means the gravity is created. That is how gravity is created. Gravity bends towards folds and warps in the space-time continuum. Like I see, we will never be able to even like perceive time, because we can only see in 3 dimensions. Our brain can only process 3 dimensions. Time is a 4th dimension that we will never be able to see and that we will never be able to perceive. We can only perceive it through math and like other calculations and weird other stuff. So, how time, because of the space-time continuum, essentially works is that time travels slower and slower for things traveling close to the speed of light. So a photon travels at the speed of light. That's what makes them all lights. They're massless particles that travel at light speed and then create all the light that we see today. They travel slower and slower. Time, relative time, works for them slower because they're traveling so fast at the speed of light. So, because of this, time is considered the 4th dimension, along with when you have your length, your width, and then your height. Time is the other one. Things that travel faster to the speed of light have more of a relative time, a slower relative time compared to other one. So, because of space-time, it allows scientists to describe things like the orbit of far-off planets, and since those far-off planets, the relative time of those planets is slower than our relative time because of perception and other stuff. So, and it also allows for scientists to even like describe the word relative time for everything. Everything in the universe has a relative time based on the space-time continuum and its speed close to the speed of light. Whew. I just tried to explain something wild to you, something that some college students spend years investigating, years of their life investigating. But yeah, that's a very, very, very elementary version of it. It's like scraping the surface of space-time. And yeah, that is the space-time continuum that envelops our universe, and who knows what will happen in the future with the space-time continuum. Fun fact, this is something that changed the future. All this stuff that I just described with the space-time continuum make up something called Einstein's theory of relativity. Relative time, how relative time travels slower for things that go faster than the speed of light, or things that approach the speed of light, time goes slower. That is the theory of relativity, and the fact that we have our fabric of space, and that if you pull down on that fabric, you can create gravity as it bends towards, light can bend towards that. Yeah, that's the theory of relativity. That's it. C'est fini. It is over. That is Prietology, done and dusted. What a seasons it has been. Space-time was our final term. Yeah, now we've concluded. That was the end of Season 5. We are done. We have completed 5 seasons of Prietology. Let us go through the best moments of Season 5, and then we'll conclude the whole series. Well, hello everyone. Welcome back to Dprieto TV. I hope you like travel tidbits, but finally, since January, we are back with Prietology Season 5. Uranus, not Uranus. Ha ha. It got hit sideways, and now it's spinning like this, but now it's tilted like this, and it spins like this on its axis sideways. Halley's Comet. I forget who it's named after. Hold on. I'm looking at the astronomy book that we have. Well, it technically wasn't created, but its orbit was predicted by Edmund Halley in 1758. You know some constellations. You have Virgo, you have Gemini, you have Scorpio, you have Aquarius, you have Pisces, you have Taurus, you have Aries, Cancer, Leo. They shrink down like a funnel. They get thinner and thinner and thinner and thinner and thinner and thinner until they shrink into a point, an infinitely small point, which is called spaghettification, or being spaghettified. As you know, spaghetti is a noodle. It's a very long noodle. Yeah, like I said, happy holidays. Christmas time. As you can see, my place is a bit decorated. As you can see, there's a stocking here. Hopefully there's something in there by Christmas Eve. So yeah, it has taken some of the most beautiful pictures, won awards for some of the most beautiful pictures of space you've ever taken. This was taken by Hubble, this one. Next episode is the final episode of Season 5 and the final episode of Prietology in general. It's the series finale. Do not miss it. It'll be a full-fledged finale. We'll celebrate the past 4 incredible years of Prietology and the 5 seasons that we've been able. I cannot tell you guys that 4 years ago, doing this, all this for so long of a time, unfathomable. Unfathomable that I would be able to do this for so long. After I made the first Prietology lesson, I'm just like, okay, this is a good video. And then I saw how popular it became. I'm just like, okay, I'll keep doing this. I'll make a few more videos. And then just like, all right, we finished all the chemistry. Do we want to do physics? And then we finished that. Do we want to do biology? Then earth science. And then now astronomy. We've done 5 seasons of this, guys. This would have never, ever, ever, ever been possible without you guys. I want to thank you so much for your support over these past 4 years to support Prietology. You guys have done amazing. We've talked about chemistry, physics, biology, geology, or planet Earth science, and astronomy. We have done so much over the past couple of years to do so much in Prietology. We have talked about we have talked about chemistry, physics, geology, astronomy, from acids and bases to nuclear physics to cell biology to the layers of the earth to the solar system to space-time. We have done so much. We've covered a lot of scientific knowledge and terms. Who knows what lays in science for the future? I hope I've inspired you guys to maybe at least consider a career in science. I hope if this has encouraged you to to start pursuing a career in science, cool, could pursue it. I want to pursue a career in science. I want to become an aerodynamicist. We didn't talk about aerodynamics because that's such a super complex topic in physics. But yeah, if this pursues you to do physics, do it. We cannot wait to see what the future of science looks like. And if it's with you guys, that would be absolutely amazing. We have done so much in Prietology over the past 4 years. Here's the stats. We've done 5 seasons, 30 episodes, including this one, 222 terms, including this one, and this is the best one, over 530 minutes of content in Prietology. We have done so much of these past 4 years. I would have never ever been able to do it without you guys. It's going to be sad leaving this. This has been a part of my life. I've circled my life around this, having to do this like once every weekend, balancing with gaming videos and travel and other miscellaneous videos that we do. But yeah, now that we're no longer doing Prietology, now that we are finally concluding it here in the series finale, I'll find something else to do. Don't worry about it. So, some announcements. Now you're probably wondering, David, what's going to happen to Prietology? What's going to happen to that? What I'm going to do is I'm going to divide the Prietology playlist into 5 separate playlists, each of them for a season. So if you want to binge season 1, season 2, 3, 4, 5, and learn about chemistry, physics, biology, geology, or astronomy, go ahead. And I'm also going to make compilation videos. I'm going to put all of season 1 in one video, maybe it's like a 2-hour, maybe long video, all of season 2, all of season 3, all of season 4, all of season 5 in one videos, and that is coming soon in the future. I will make that soon. So, I hope you enjoy that for the future, the new Prietology. I'm reshuffling it. But in terms of new videos, here's what's coming soon. On April 29th, we are continuing the Cuphead Blitz. The Cuphead Blitz will continue on April 29th with the 14th. Week after that, on May 6th, with Cuphead number 13, with Cuphead number 15, and then on May 13th, a week right after that, is the final Blitz with Cuphead number 16. So, that is all coming soon. Get excited for that. So yeah, that's all coming soon for Prietology. For Prietology, that's kind of it. We're done. Thank you guys so much for supporting Prietology over the past 4 years. Whether it was watching it, making chapters for the videos, yes, I see some of you have. Thank you for doing that. That helps a lot. Or subscribing or liking a video even, or even putting a comment. I've seen some of you guys put comments under the videos. Thank you so much for supporting Prietology in any way you guys support it. Thank you so much for these past 4 years. I've super enjoyed making these videos. I'm a science buff if you haven't seen me making these videos over the past, 30 episodes of this series. Thank you so much for supporting this, guys. I wonder what the future will bring, not in just terms of the channel, but in terms of science. I hope that you guys pursue a scientific career. If you don't, completely fine. But thank you so much for Prietology for the past 4 years. Thank you, guys. See ya.